knows a lot about it.
Yeah, astrophysics is, it's all observation. It's all based on observational science. So you're just determining, distances and ratios. You're trying to calculate distances and ratios.
That's all. It's just distances and ratios. That's all
So
it
you
is.
treat the
All right, I
space
asked, is
between your points
superfluid
of light
vacuum?
as a medium
Oh, you're going to talk now. Okay.
rather than
We're
empty
listening.
space, rather than space-time bending.
And then you don't need any Einsteinian relativity, right?
Makes sense, right, Josh? Do you agree, Josh, that astrophysics is observational science and not testable experimental?
I mean, I think anything is observational.
And specifically astrophysics, it's based on calculating the physics and the mechanisms of where these points of light in the sky appear. Astrophysics is just based on the observations of where things are in the sky and the physics of how they got there. Based on calculation.
It's not where they are. It's how hot they are, what they're made out of, how fast they're moving, how long they've been there.
Right, yeah, and all that is calculated based off of the observations. The dimness of the light, you calculate the lumens, right? All the forces and the temperatures is calculated from the the amount of redshift to the light. You give things a certain distance based on how much they're redshifted. So that's all just calculated based on the light, like how much the light is redshifted. But it's just based on observation. That's not really science. Like that's why they call astrophysics observational science.
That's still science.
Yeah, Pfinky, I don't care. Sorry, but you got a lot of catching up to do around here.
Yeah, I guess where that falls apart from my point of view is because I feel like the logical next step there is saying that, oh, well, what if the medium isn't what it's claimed to be, right? And things are bending and moving in ways that that are out of our control to be able to predict. But then I would push back and say, okay, well, we've sent out probes and other things that have existed in that medium, and we've corroborated that, light and things move in the ways that we've predicted. So I guess I get why you're trying to push for it to be, an observational science, because then you're able to throw sand at and obscure, the entire understanding. But I push back against that assertion.
Yeah, well, astrophysicists before NASA ever claimed like, hey, I'm testing the medium 500 miles away now, 1,000 miles away now. Before that, all of your distances and ratios and forces, they're still based in the calculations. Kepler's law, still based on ground observations. Orbital mechanics, still based in Kepler's laws. You know what I mean? Like, even though you claim you took a satellite and tested your claim, your claim is still based on a calculation that is based on a ground observer position.
Well, that would mean the vacuum is nothing, right? And if you test
okay,
it,
so you acknowledge I'm right. Thank you. That's right.
Yeah, it is. It is observational science. Good job.
But I would, I can agree with that, but I can't agree with the, the next step there by saying that the medium is different than what is claimed.
Well, yeah. How are you testing what's in the medium? You know that they say barometric pressure gauges don't work after a certain altitude. So how are you actually measuring the atmospheric pressure? And who's claiming to even send something that high?
We use ionic gauges
and Elon Musk and Pfinky. I was
after
still talking.
Barometric.
I was going to say you can check out the link that's in my bio. The external pressure sensor at the ISS, like it walks you through the entire payload tech of how they measure it. So if you're interested,
he's not.
Yeah, is it a barometric pressure gauge or what are they doing to measure the relative pressures?
It's an ion. It's not.
They say there's nothing out there, right? What is it relative to? The pressure in space is close to nothing.
Yep, it's called an ionic gauge.
Yeah, it's not a continuous medium. Yeah, it's not a continuous medium, so it measures individual collisions.
I'm surprised you
Okay,
didn't
so
know
not
that,
the
Alec.
pressure of the actual space in the environment, but just individual collisions due to like dust particles, space debris.
So a collision
No,
imparts a force on a specific area. Force over area is, drumroll please,
Not due to the actual
pressure.
medium that they claim it's traveling through. You just said that the pressure is because of different little whatever pockets and dust. It's not telling you the
it's not
pressure of the
dust.
medium.
It's not dust. I'm surprised you don't know this though.
Yeah, this is where
You guys don't
this is
even
where
you
it
don't even know
matters
how
and
to
where it
measure
falls
air
apart for you
pressure.
guys.
Well, but I know, but like if you don't even know how they measure pressure up that high, then like what are you doing in the conversation?
But of course, we need Pfinky to just cheerlead and not understand anything going on.
That's
Oh, I'm
just
sorry,
meta.
man.
Meta
You've been
saying nothing.
demoted. You've been demoted, man. He didn't attack me.
Yeah, I mean, Pink, are you just trying to create more dramas? It seems like
No,
you're kind of
no.
just trolling him at this point. Like, I mean, he kind of chilled out. We've been chill, and then you're like still trying to poke at him.
I mean, I don't
Yeah,
know why
I
the
don't know.
people that are the
Every
worst
time
at
I
this get
talk here,
special
every time
privileges.
I
Like, is
say,
that the audience that we're trying to have? Like, we want more Pinkies, do we? Is
well,
that
hold on,
because
Gio.
if that's what it is, like, I'll leave you guys alone.
Okay, you can leave us alone. Every time I've said anything, he's insulted me, Gio.
Like,
So
does the audience
is that
want
what you want?
Pinky and his shenanigans more than other stuff?
Well, you lost the vote earlier pretty bad, if I recall.
Hey, what's up, Wesley?
All right. So, what was the topic?
It's about relativity and astrophysics because the whole field of science is being overhauled.
But I mean, I feel like
They're applying quantum where they once applied Newtonian gravity and Einsteinian gravity.
who's they? Like, I still haven't gotten that.
Yeah, it's not being
The people that have gone together. Okay, so the people that come up with these new theories about what's happening in astrophysics, it comes from like teams within universities and peer-reviewed papers and the whole process of getting your thing publicized. The only way you even find those kind of papers is after it's been passed around multiple universities, and then at the bottom of the link, it shows you the number of the people that peer reviewed it. So, like all of them, all the
I
people
mean,
that peer
just
reviewed
Ron's the scholar.
that
He just
theory.
Here, how
He
about
just-
here? What do you guys know about MOND, like modified Newtonian dynamics?
negatory.
It's called modified Newtonian dynamics. Yeah, these are like alternatives to general relativity.
I think my main beef. I'm not saying that
Yeah, like
people
the sun
aren't
isn't the
studying
center
this.
of mass, causing a pull force. That's officially like out of the question right now.
There's MOND and then there's RMOND as well. RMOND is relativistic modified Newtonian dynamics, which is somewhat in what you might be referring to, Alec, because there's like quantum mechanics that are in the electron spin lattice interactions that are part of like modified Newtonian dynamics. So like the using quantum, and then also like you were saying, there's like superfluid theories as well.
Thank you,
But none of these
Gio.
are remotely
I should be
close to
providing
being
articles at this
supported.
point, but yeah, I know what I'm talking about. I've read what I'm talking about over the years, so at some point I gotta just let people indulge the way I have.
How about this one? The relativistic spin lattice interaction proposed in 2025 is a new framework to unify relativistic and quantum effects within solid state physics, offering improved predictions for spin distributions and currents.
I mean, there's a bunch of these things. They're just none of them are remotely widely accepted. So I think it's great. I
Did
think
you just post that?
try to. You talking to me?
Yeah,
Anyway,
but why does that really, does it matter whether it's accepted? Because even if you believe the Earth is a globe, there was a time where it was very not accepted by virtually everyone, and allegedly it was a globe. So that was the truth in your view, and it was widely not accepted. So the truth is not always widely accepted. I mean, you agree with that, right?
I agree. Yeah. Though, I mean, if somebody comes up with the correct unified theory, then it'll gain traction. Right now, none of these are gaining traction.
I found
Did
like 3
anybody even
papers on it.
understand what Gio just said? Spin lattice. Does anybody even know what that means? Because I surely don't.
Negatory.
That's what I thought. Look, they just make shit up, bro. If you're high enough in the ranks, you can just come out with any nonsense, any mathematical or anything that comes in your mind, and
All right,
they'll
I'm
get
gonna-
peer reviewed. Yeah.
All right, I'll read this. This is on relativistic spin lattice interaction. It says the new framework is known as relativistic spin lattice interaction (SLI), which emerged in 2025 as a way to unify quantum mechanics and relativity for electron behavior in solids. It allows for computing spin dynamics without the problematic orbital angular momentum operator, improving simulations for spintronics. Boy, that was hard to pronounce that all or get that all. That almost
Oh,
sounds
that
like word
makes
salad.
sense.
It almost sounds like word salad, but I don't think it is. But yeah, problematic orbital angular momentum operator for spintronics. Yeah. So I guess this has to do, with like electron behavior in solids. But I mean, it's also some of the way that quantum physics is. I mean, what you may or may not think of quantum physics, which is interesting because it might be tapping into what the actual ether is on some level of it. I'm not saying all those theories are correct, but there's definitely, I mean, the relativity is like very.
Well, thank you, Gio.
It's all made up nonsense. Nobody here understands what that is. Even after Gio read it, I'm sure nobody here understands what it is.
The
Right?
lattice
You know
the
why?
lattice represents your point in a gravitational well. The spin rate is correlated to an amount of mass and size. It's
Okay.
modified Newtonian dynamics. Like I low key get it. I never actually indulged in that part of the spin lattice. Like I do want to understand it, SE, honestly.
You can't understand nonsense, bro.
It's about it's just inverse. It's like distance. You're just calculating the pull force based on distance. It's just inverse.
Which means what?
It means that they're trying to create a quantum. It's like a quantum fluctuation field, similar to quantum. The mechanisms in the field, like around like an atom or an electron, they're establishing field perturbations that affects the pull force, quote unquote gravity, like why things are being attracted to each other in deep space. But
Right.
hey, man,
But
I'm
that,
just hearing what Gio said just now. I'm not acting like I know what's going on exactly.
no. Don't get me wrong. With all due respect, I just want to bring up a point, and I can post dozens of stuff what Gio just posted. Right. Just yesterday, I read a paper where now they're accepting the doubling of the age of the universe. Right. They come up with all these crazy things all the time. Right. And they all fight with each other. Trust me, none of it makes sense. Even in their model, it doesn't make sense. Like they'll put a gap here to fix this problem, but then another problem gets brought in, right? There's no such thing as unifying one grand unifying theory because of the fact that gravity does not work in the quantum level, and they're never going to make it work ever because
Well, Etsy,
it's just not there.
what do you think of the superfluid vacuum theory?
Yeah, exactly. And that's what they say is happening when stars form. They say that gas molecules, like the atoms of a gas molecule in the early stages of the Big Bang, that other gas molecules are attracted to their center of mass. That's Jean's instability. That's how stars form in the Big Bang. In quantum
Again,
mechanics,
just
gas molecules, no, things don't move towards their center of mass. Electrostatic spatial fields cause electrochemical fusion and separation. And in quantum mechanics, it's not attraction to a center of mass to clump into a liquid. Like that's completely Jean's instability is proven false. And they still claim they know why stars form in a vacuum. And that's why we have suns.
exactly, it's contradictory terms, right? It's like I said, how can gases amass in a vacuum? Just you don't have to know quantum physics, right? Just you have to know how vacuums work and how they claim stars form. And it's not possible. It's just not possible for a
Seems
gas to
possible.
amass.
Yeah, no, they definitely have it
Correct.
wrong. Like the mainstream model is definitely wrong in my view. So, you know,
Yeah.
so that's definitely not it. But I mean, dude, some of this quantum physics stuff is interesting though, and like I'm sure there is stuff in it that's not legitimate or that's like too theoretical or not like experimentally validated. But I think there could be components of it that could actually be like very cutting edge. Because I mean, dude, there's some like the sky is in like the word orbit might imply like spheres, orbiting spheres, but if we call it a circuit, or even if you call it an orbit, these lights in the sky are moving in these very unique ways. Even like the when you have Jupiter, whether you think those moons are going around it or they're phasing back and forth. I mean, there's obviously like this interaction between, you know, those bodies. And then we have like the cells in the human body and fluids and all of these different components. So whatever the sky is made of, whatever like maybe matter is made of, the macrocosm to the microcosm may all be interrelated on a much deeper level. And if we bring in ether, I mean, ether might be the ultimate integration and like recovering in the, you know, the ancient understandings of it with the modern day. But I mean, I think that's what's going to be coming back ultimately, like in the larger, because quantum physics is like, I think they're tapping into certain things that are related to what ether is and how it functions, but they're just using different theories and names. But I'm just saying, like, there is a deep need to want to inquire as to what is behind all of this, you know? And if it's not the mainstream model, then what is actually occurring, you know?
Oh, absolutely. There should be inquiry. There should be. I'm like definitely I want to know this stuff, right? But we have to like distinguish made up stuff, what's possible, what isn't. I mean, everybody's entitled to their own and to their own and to their own opinion. But a lot of this stuff they contradict themselves. They fight with each other. Like a lot of people think that all this is agreed upon. No, it's just this guy comes up with this theory, then another guy comes up with that one, and they try to do a mathematical formula to make, like dark matter and dark energy and all this stuff, right? It's like
But
I'm all for inquiry, but don't make stuff up, just don't do it.
aren't you conflating though the theoretical part with the established part? I don't think that there's any conflict in the how stars form.
Yes,
Oh,
there is.
absolutely. There is. There definitely is.
Okay, and can you cite that?
Well,
Well,
that's
sure.
what
I
dark
can tell
matter's
you
for,
from
man. That's sorry. Yeah, that's what dark matter's for.
No, there's nothing about star formation that has to do with the way galaxies move out on the edge of the universe.
well,
To say
you
that
do
we don't.
understand.
Oh man, sorry. Go ahead.
Go ahead, bro.
It's just so ironic. We don't have a problem with how stars form in a vacuum. What is dark matter? Dark matter is the placeholder variable for what causes things to coalesce in a vacuum in deep space at
No,
an
no, no,
astronomical.
no, no, no,
Yeah, it
no.
is.
No,
Yeah, you
no,
need
no,
things
no,
to move
no,
towards the
no.
center of your galactic. Need things to move towards the center of your galactic cluster. You claim that there is a dark matter halo, which acts as a placeholder for the amount of mass you need for your gravitational well.
In a galaxy on the edge of the
The
universe.
galactic cluster in the early stages of the universe. Yes,
Yeah,
Oh,
notice how
dark
we went
matter's
from
form.
do you think?
star
Do you
formation
think
to
we
the edge
had?
of the galaxy.
Do you think we had a hypothesis on how stars were formed before
Why
we
did three people yell no? I don't understand that. That's
identified dark matter?
I think you were just wrong. That's why 3 people jumped in.
So, yeah, do you think that we had like a hypothesis or theory as to how stars formed before we identified dark matter?
yeah, and then relativistic equations showed that you needed more mass. You was 83% missing mass. So
Wait,
you
we
invoked an
needed more
invisible
mass for
halo.
stars to
You
form?
invoked an invisible
We needed
halo
more
around galaxies.
we needed more mass for stars to form?
They rotate at a certain rate, which gives them a certain amount of mass, which gives them a certain amount of pull, which
Talking about
creates a
Galaxies
certain.
or
galaxies.
stars? Galaxies or stars,
It
Bill?
sounds
Why
like
don't you guys
you
know
know
this? I
the
have
answer
to
to the.
explain
Sounds
stuff
like you
about
know
your
the answer
model.
to
This
the
isn't even
question,
my
which is why
model.
you won't answer it straight up.
I am answering it. You're
Sounds
talking
like you
through
know
me.
the answer. Yeah, so we don't need more mass for how we came up with the idea of how
So
stars are
why did they
formed.
invoke invisible mass around galactic clusters? Why did they do that? Why did they come up with dark
Be-
matter and dark energy, dude? Why?
Not for star
Because
formation.
because we
Because it's
identified like
oh my
the
god.
rate.
You guys are
Okay,
giving me
you wanted to
layups,
answer
dude. This
for
is
me.
weird.
You wanted
Honestly,
to
this
answer
isn't
for
even a
me.
real
That's
topic.
weird.
This is not a real
That's
topic.
weird.
It's a layup.
I
So
have a
you wanted
question
to
for
answer
Alec.
for me.
Alec, how do stars form in SVT?
Yeah, you're just wrong.
This
What is dark matter?
How
Why
do
did they
stars form
invoke
in
dark matter?
SVT? How did stars form in the SVT?
In superfluid vacuum theory? What a weird question. Malform question. Yep.
no, it's
You
not.
guys do
It's a
realize that nobody knows
legit.
how stars formed, right? I mean, can we agree on that? Like, you guys
Yeah, we've
Oh,
never
really.
formed a star in a
I can
lab.
walk
We've
you
never
through.
formed a star in a lab. We agree. I agree with that.
Yeah,
Yeah,
I
Gene
So
mean,
didn't
nobody
know it.
knows how stars form, right?
but we can
So
verbalize it in layman's terms fairly easily.
Watch
no,
him
you
invoke
can, bro. You were
pseudoscience
sold a
immediately.
story by some scientist, and you believe it. But in reality, nobody, and I mean nobody, knows how stars form.
Well,
And
you
if
Well,
you
can
that's
can't
just
accept
an
replicate it.
that,
opinion.
You can replicate it to a degree with sonoluminescence, and they call it star in a jar. So, granted, that's not a star, but it is something that seems to resemble what stars may be, and you can do
And
that.
we definitely have like
well, a
theories
pistol
on
shrimp does
how.
that too, Geo. But that's not really a
Yeah, it's a
star.
natural thing. That's what I'm saying. It's a natural process, and it involves liquid. So you get into the superfluid part, and it does make sense that the stars may be, because it's basically sound that's vibrating in an air bubble that's cavitating, like a cavitating air bubble, and then the sound, and that emits light. So it's pretty interesting. I mean, it's not like proof that's what the stars are, but I mean, they call it star in a jar, and you can replicate it in a lab, and it looks quite a bit like a star. So, I mean, yeah, that's not proving how they form, but it's at least showing that we can replicate something similar to them with sound and vibration.
Well, yeah, I'll grant you that, but don't forget it only lasts for a split second, right? So, yeah, my point still stands. Nobody knows how stars really form. Like they have ideas, they write papers, they teach this stuff, but really nobody knows how it happens. I mean, we got to be honest with ourselves.
I don't think you're being honest with yourself.
You can believe whatever you want, bro. Fact of the matter is, what I said is 100% true. You can accept it or not. That's entirely
Right.
up to you.
So,
Personally, I don't care.
You're telling
let me
me
respond to what Geo said. Geo
there's
about
not
the
a
sonoluminescence.
single scientific theory about how. Okay.
Okay, he wants to object and not make any interesting information come forth. But sonoluminescence, okay, so on the globe model, your guys' points of light in the sky, like the sun takes 8 minutes to get here, right? We're seeing 8 minutes into the past.
The sun's
And
not a
like they
point
talk
light, by
about
the way.
galaxies, like because of how redshifted they are, this is giving us a distance, right? We're seeing a point of light, but because it's like millions of light years away, we're seeing something that happened like millions of years ago. So you can apply this same time dilation aspect to the sonoluminescence and just say, oh, we're just still seeing a point of light from however long ago. So you can have sonoluminescence. Yep. Because they want to talk about, oh, this point of light, you shouldn't see it anymore. Dude, your galaxy exploded 1 billion years ago. We still see it. We see 1 million years ago version of it in the globe model. So you can have a point of light still visible from however long ago due to sonoluminescence.
Well, that's another idea that they've sold to the people, and they believe it, that light travels forever, could travel for billions of years. Excuse me, billions of years. And again, there's absolutely no proof of that. So all this stuff that you guys are repeating, some other man told you and you're believing it. Like, I'm sorry to put it that way, but there's no other way to put it.
I sort of agree with that. Like some other man is telling you about SVT and you just believed it.
Yeah, same exact thing. Nobody knows what it is. I mean, I love the superfluid theory. Don't get me wrong, right? And it can explain like gas not going into vacuum, but gas becoming cold and becoming superfluid. I can buy something like that. There's no proof of it, but it sure beats gas next to a vacuum, which is physically impossible. So, I mean, we can discuss possibilities, but to say for sure,
But it
I
is
mean, I'm
possible
not
to
in that
have
camp.
like a gradual decrease in pressure in the air.
That is correct. That is physically impossible. Yes, that's correct.
And it's impossible to have a gradual decrease in pressure in the atmosphere?
Next to a vacuum, yes. It physically
No,
impossible.
that's not what I said. Okay, just listen very clearly. And is it possible to have an atmosphere where the pressure of the air decreases as you increase in altitude?
And listen to very carefully what I said. Not next to a vacuum.
Okay. Okay. I'm just asking just one basic question. Can you have an atmosphere that decreases with pressure as you increase with altitude?
Not next to a vacuum.
Okay.
You can say it
Okay.
100
Apparently,
times. You're going to get the
I
same answer, my friend.
yeah.
Because you're
But
trying
you're
to
not
tie it to
answering the
what you
question.
believe.
You're not answering the question.
It's okay. I can do whatever I want. You want to ask it again? Go ahead.
Yes, that's true. I can't force you to answer the question,
Dude, he
but it's
answered
weird
it.
that you
Not he
won't
said
answer. No, he
it
didn't.
is an answer. Yes, it is.
I want to put
It
I
is an
want to put
answer.
a funny idea in your guys' head. So
It may
when you
not be the
watch,
one you like, but it's an answer.
sorry.
Go ahead. No, go ahead.
So this is an observation I made that I don't really get to bring up. When they say that Jupiter is rotating, like the angle that you see the rotation, like the things that pass over the planets, it literally makes like a straight line. You don't get to see any of the actual, it doesn't reflect the sphericity. You see like a straight line path across the planet. And then when you see the eclipse, you see a straight line path as it perfectly eclipses the moon or the sun. So the idea is like, are we watching a medium pass over a point of light? Because that's what it looks like. You watch the eclipse, it looks like you're watching a hole and like a lid cover the hole. And when you look at Jupiter, they say that like it's orbiting like the sphericity of a planet, but it just looks like a medium passing over it. That's what it really looks like. So I urge everybody to go look at these guys like Tactical French Cat and Seafoam and Bob the Science Guy. They take their expensive telescopes and they look at planets and they don't see sphericity due to the rotation of the planets. Like apparently the planets are rotating, but they don't show like the actual curvature of the planet. It's just straight path. It's like gas passing over a point of light. But yeah, I just want you to think about that, honestly.
I mean, they look pretty spherical, though. You don't think Jupiter looks like a ball?
If I can get in here for a second, we also have videos of Mars rotating, and Mars is not Jupiter, it's not a gas giant. I was able to view that in my telescope. Care to explain what I was looking at?
Oh yeah, Mars rotating. Yeah, does it reflect any actual curvature, like the things that you see passing over that point of light?
Yes, so like surface features can be seen, and those surface features on that sphere are rotating.
All right, so
So
go ahead, time lapse. Let's see it, bro.
can I screen share on this thing? Because it says I'm not allowed to do camera.
Yeah, I'll give you the roll.
I can do that. I'm going to be allowed to. That's excellent. All right, let's see. Get onto use screw here. Hang on. Let's do.
Oh yeah, you've already got it. Yeah, you've got the roll, so you should be able to. Yeah.
So I can do that, and it's not going to kick me off or anything.
Yeah. No, you're good. Are you going to share camera or screen? And I can share it on the live stream as well. If you're going to do, are you going to do the actual share screen? Because the only thing is, you know how Discord has a limit to like 25 people, I think, with the camera. That's all. But yeah, we'll make
Wait,
do
there's
with
a
it.
limit?
Well, okay, so you know how you can share your screen or you can share camera. All I'm saying is that if you share camera, Discord has like across all of Discord, there's a limit. It's like 20 or 25. It might be, I think, yeah, to where like it won't let more than 25 join the voice channel. It just locks other people out. But if you share screen, it doesn't have that issue. But I was just asking which one. But either way, yeah, whatever you share, I'll share it on the live stream. Oh yeah, you're just sharing
Yeah,
screen.
yeah, Reds, could you please show your face cam, please? Pretty please.
Unfortunately, that is a violation of the Geneva Convention. I am hideously
Rhetoric. I've
ugly.
heard of you. What's that?
Sup? Anyway, so if
Cool.
we
I
go,
summoned a big dog. Look at this. Now this guy has to refute what I'm saying. It's funny.
Well, I'm gonna share your screen on the live stream just so you know if you're good with it. So it'll be on the live stream as well. Just
And
so
we've
you know.
got you.
don't care. Anyway, so if we go to my video, Flat Earthers Lacking Focus and Common Sense, we can go to this part of the video at around 13 minutes, 28 seconds. You can see the gigantic telescope. Let's just take a moment and take this beautiful piece of optical badassery in for just a moment. Oh, yeah, that's good. Okay, anyway.
Don't waste my time, dude. You have time lapse of Mars reflecting sphericity
dope,
along the surface. Remember that
Oh,
part?
look at that. Mars rotating. Oh, man. Eats your heart out, doesn't it? So here you can see the surface features, and here you can see the poles of Mars, and here you can see it's actually rotating. So care to explain what I'm observing right here, if not rotation?
Yeah, it looks like the path is, well, it's over already. We didn't even get to really look.
Hang on a second.
Yeah. You want to post that video so I could take a bigger look at it?
What do you mean posted? I'm sharing it.
Yeah, just post a link to the video.
Looks like a rotating planet to me.
Yeah, hang on a second. Copy, and where do I just
People are
DM it to
going
you?
to insist they
Just put
are
it in,
seeing what they
live
believe,
stream one
because the
text.
mind does that. But I want to focus.
Hang on.
Hold on.
I'm getting
I
two
want
different
to stop
instructions right now.
interrupting. I don't care who you are. I was saying something. We need to focus on the path. Okay. So you're claiming that there's an angular momentum to the positions of things on the surface, right? So we can calculate the path based on the observer position's relative angle. You know, based on where they are on Earth, which direction Mars needs to be rotating. This is the actual crux of the argument. And find
Actually,
out
what I was
how much it
saying.
really corresponds to your globe calculation based on the observer position.
Actually,
And
what I
I
was.
don't know where you took this video, and honestly, it doesn't look like it's rotating. It looks like what I said. Looks like gas passing
Actually,
over
what
a
I
point
was
of
saying was, where do you want me to post the link again? Because I'm getting two different instructions.
Yeah. So
yeah. What if
I
someone's telling you,
you
you got
on
a handler right now?
electric. Just hold on, bro.
Thank you very much.
Yeah, I tagged you, and it's a live stream one text. That's where we post everything for this
Live
channel.
stream tag. Okay, hang on one second. Live stream one text.
Yeah, I tagged you.
Okay.
In there. Yeah.
Okay, hang on one second.
Yeah, so that whole Mars area is just one big volcano.
Okay.
By the looks of it.
Let me get back on. Hang on a second. All right. All right. The link has been shared. Is that sufficient? Did I post in the right spot? I don't know if it has the time code embedded within the link, but if you want to know the thumbnail that the time code that you should go to is 13 minutes and 34-ish seconds, so that you can click on it and see it for yourself. You can unmute the guy that was very eager to speak.
Yeah, he was talking about like the angle that it's.
Angle something. I
don't know what makes what you're doing okay. We were having a conversation. Okay, the conversation is about observing the rotation of a planet. If you look at what your observation shows, you require an equatorial plane cutting your sphere in half and then reflecting the points along that spherical surface showing rotation. What I just saw doesn't look like that, honestly. It
Cool.
doesn't
Then
look
what
like
am I
what you
seeing?
need. It's not
What?
even close.
Then what am I
I don't see
seeing?
an equatorial plane. I don't see it.
What am I seeing?
What does it look like to you?
Yeah, what am I seeing? What was
A
captured in the
wobble.
But
telescope?
this
That's what it
server is
looks
just
like.
bogged down with, you wasting time, I guess. That's what we're gonna do now.
Okay, so it sounds like you're just coping at this point. Please explain what I'm seeing.
That's a lot
Like
of
I described
rotation
a hundred
for no
times
light.
before you were, instructed to join by someone. Gas passing over a point of light.
This is a solid surface. It doesn't move.
Oh, the surface of Mars doesn't move. You see
It's
how you have to
static.
make
It's
a
a static.
misnomer?
It's a static
Make
surface, which
misnomers
means
while
that if I
believing a
see it
globe.
rotating, if I see a static surface rotating, that means the planet itself is rotating. This is not something you can blame on clouds.
Yeah, but like I said, dude, based on the observer's position on Earth and the angle that you're facing and the time of
What does
day,
the observer's position on Earth have to do
yes,
with anything?
this will make a calculation
What?
for the axis of rotation and the angle based on
So,
the
Reg,
observer's position and which direction you're supposed to observe rotation
Can
and the
someone
what it
decipher
changes
has
that
to
for
of the
me,
do,
please?
what
position
it has
along
to
the surface.
do with
He's going to have to
is
Very
shut
the
up
amount
and
of
simple concept,
straws
and what we
is the
observe
amount of
in your
straws they're
photos.
grasping at. That's
hang
that's
on.
Yeah,
what it has
that's
to do.
I'm
Hang on,
talking.
guys.
I'm
Yeah,
talking.
you need
So.
to stop talking, Lick. You need to stop talking. Let
Oh, I'm
someone
sorry.
that
Is
is a
this a
respond.
lot of
complete
nothing. I
globe
heard a lot of
meltdown?
nothing
Are
in
you guys
that.
trying to have a meltdown or have a conversation? Which
I'm
is
just trying to get an actual answer out of you, and you're somehow bringing up the observer's location when I'm looking at Mars. I can look at Mars from many different locations on
yeah, I
Earth.
want the
It doesn't matter.
calculation. Oh, I'm sorry. I want the calculation for the angle of the
Calculation
axis of
of
rotation.
what? Be
I
deliberate with your
just
Stop
told
words.
you.
trying to
I
have him
just
dox himself.
told
Stop
you
trying to have him
the
dox himself.
angle of the axis of rotation, which will give you the angle of the equatorial plane, cutting your sphere in half, and that will reflect
What
your
define
axis of
equatorial
rotation.
plane for me,
Oh,
please?
you don't know what anything I'm saying means.
Hang
How
on.
funny.
I don't know.
Would
I
the
don't know
state
your definition of the word that you are saying. Yes. So define equatorial plane plane
Cutting
for
a
me,
sphere in
please.
half. Cutting a sphere
Cutting a
in half,
sphere in
and
half.
it is
Okay,
the.
so an equatorial
Okay,
plane
so
is
do you
about
want to have
cutting a
the
sphere in
conversation
half.
because you just
How
asked me a
do we
question?
apply that to this observation? Go.
Okay, you're a waste of time. Red's
Okay,
rhetoric. We
so you
know
have
you're a fake
nothing.
glober.
So Alec was very easy to debunk. Do we have an actual challenge?
Your
Next,
observation
please?
doesn't reflect what needs to be observed based on the
We can
calculation.
literally see a planet rotating, and you're just coping at this point. That's fine.
No, it's not rotating. Clearly, that's not rotation.
No, that is rotation. You're just coping at
Oh
this
no.
point.
Well, you need to take a closer look because I've
It
taken
looks
the
like
closer
rotation
look,
to me.
and it doesn't look like it's rotating.
We have
I want
an 11-inch telescope. We took a close look
But
at it. My guy.
we should also take a closer look at the observer position relative to Mars
And what
in the
does
globe model.
the observer position have to do with it?
It'll give you
let
the
me
angle of the axis of rotation relative to the observer position.
The
And
axis
then
of
that'll
rotation
tell you
relative
how
to the
you
observer's location
that'll
is
give
is
you
is
where.
different. How, if I were to
Aw,
observe
poor Red's
Mars,
rhetoric. Oh, you don't
if
understand
I were to
sometimes?
observe Mars from Massachusetts and I were to observe Mars from Florida, how would that change the observation? If you cannot give me an actual answer to that question, then you are full of cope. You should move to Copenhagen. They're looking for tenants.
All right. We don't have to necessarily go there. I did put him on temporary mute for a minute so you could even respond because he wasn't stopping talking. And Electric, I'll unmute you, but bro, you got to chill so we can have a real convo. And please stop all the trash talking and stuff because it's just going to derail the convo and stuff. So Rez, I think what he might be referring to, okay, so they claim that Mars is on an axial tilt of 25 degrees from the ecliptic in the globe model. And then you have the globe Earth, obviously. I think what he's referring to is, does it match up on all different parts of the globe model when you're looking at Mars? Does it match up with doing that effect in relation to its 25-degree tilt to the ecliptic versus the position of the globe and stuff? So I'll unmute him, but I think that's what he's talking about.
Before you unmute him, because I actually want to get this answer out, because this guy does not know how to control himself. We did not make that measurement. We did not make that calculation because that is a totally different question. The question was, does it rotate? That was the only question we were looking to answer. Now, does it rotate at this degree or that degree? How does it rotate? Does it rotate left or right or up or down? That's not a question we were looking to answer. We were only looking to answer one question. That was, does it rotate, period. We took an 11-inch Schmidt. Hang on. We took an 11-inch Schmidt Cassegrain telescope. We were able to do a time lapse of Mars, and we saw via this time lapse that it was rotating. Therefore, the question was answered.
No, it appeared to rotate, right?
How else am I to see it rotate other than it appearing to rotate?
Wait, when you say it appear to rotate, what do you mean by that?
Yeah, it's apparent. You can only see
Gio, I
it.
want the conversation more than these guys. So let me respond.
Let me. Go ahead, Alec.
Thank you, Rob. Respect it. These guys tried to laugh and say, I don't know what an equatorial plane is. It's literally a plane that cuts through the equator of a sphere. This is how you can see an axis of rotation. If you have a rotating sphere, the equatorial plane is showing you an axis of rotation relative to the observer position on Earth, where you're making your observation from. So you can calculate, not finish. You're going to act like you should respect Red's rhetoric. Give me a moment, left lane. I wasn't finished.
It's directly to
I
what
don't care
you're
what
saying.
you're talking about. You don't get it.
Yeah, fuck
So
you,
based on the observer's position on Earth, right, there's going to be an angle that we see the equatorial plane that will reflect the axis of rotation.
What is that angle?
We don't know where the observation
It's
was
90
taken from.
degrees to the axis of rotation. 90 degrees to the axis of rotation.
What's the time
You
of
don't
day?
even know
Where
what
did he
you're
take it
asking.
from? I asked him, what's the time of day? Where did he take the observation from?
It was
Remember that
nighttime, if
part?
that helps.
Well, he posted the video.
Okay, it's Bob Nodell.
I don't know if you,
Okay, Bob Nodell. Great.
What about Bob Nodell?
but it is
Bob
all
Nodell, not giving data all the time.
technically though, like what Red said. I mean, it technically would be a red herring only because it wasn't necessarily the topic, like the angle of that effect in relation to what the heliocentric model claims. So
We already know it's not
you
reflecting.
are bringing up a
sphericity.
point about rotation or what would be rotation in that model, but are you claiming that it doesn't match the heliocentric model? Is that with
I'm
the
gonna
point?
first thing you said. It's not reflecting sphericity. Points along the surface showing an axis of rotation. That's not what we see. Not even close.
What do you mean points along the surface?
Like
Are
I
you talking
said,
about
it's more like a
surface
linear
features?
path for the textures.
Are you talking about
supposed
surface features?
mass on the surface, the discoloration, the shades.
Yeah. Okay.
seeing a
So that's
straight
what I
path.
saw. I that's exactly
Is
what
it
we see.
reflecting the correct axis angle? Like, no. How do you even know?
Wait, what do you think you see on there, Alec? What are you seeing?
Yeah, that's what I want to know.
He thinks he sees.
I mean, what do you
he sees
see
a
in Red's
wave
rhetoric?
of a medium?
That's the real question.
He says what he sees is a wave of medium
guys
flowing in
worship
front
this
of a
guy.
point light.
Sounds pretty good.
That's
I
what
don't know.
he
He
said.
already said. He said it appears to be a planet rotating on an axis. I thought.
No, that was Rob.
Well, I mean-
Rob didn't realize he wasn't supposed to say that.
Oh, okay.
It's funny, the globe reinforcement.
I
They must
knew
have been
exactly
listening
what
to
I was
my
saying.
amazing
Don't
argument.
fuck around. You wanna strongman me again?
My
That was
argument
great.
must have
Gio,
been really
is this
good
how we're
because you
gonna
guys have
operate,
to
Gio?
focus.
Today? Is this how it's gonna go?
Let's just chill for a second. Rob, do you want to have the mic? Just go ahead and say your point because there's too many people talking at once. Go
Yeah.
ahead.
I was teasing Rob. I wasn't sorry. I retract.
I'm gonna just say this again. Yes, Mars appears to rotate. How do you verify that it's a sphere rotating? Go
Okay,
ahead.
you're ahead of Alec. Alec, what do you see in this video?
Yeah, I mean, for example, like just one other very general idea. I'm not trying to like this would be more for like a speculation discussion, not as a debate necessarily, because I don't think any of us in here necessarily. Well, do we have the way to actually verify tangibly what that light is? I mean, I know there's spectroscopy. I realize there's observation, but I mean, one other just general idea. You know, how if you have like a bubble in a fluid, and if that bubble it can be rotating. There could even be little like specks of dirt or something like in the bubble or something like that where you could see that kind of rotating as well. So
Hey,
that's
Gio.
another potential. Like in a superfluid, if it is gas or some kind of a bubble or something to that effect in a superfluid, it could be related to that rather than a large gas giant, light years away. kind of
Hey,
thing.
Gio, I appreciate what you said because that is actually a valid rebuttal. So how do we know that we're not observing like a surface with a changeable medium? Well, the answer to that question is that the surface features don't change relative to each other. If you're looking at, like, for example, a cloud pattern on Jupiter, you will see that the bands actually change as Jupiter rotates. So you'll see one rotation, and if you take an image of Jupiter later
This is
on
funny.
at the same point in its rotation, you'll see the clouds have actually changed a little. But that's not what we see on Mars.
Okay, so you're making a difference between Jupiter and Mars. Well, that's interesting. I mean, the thing is, I understand what you're saying. It would expect to be more like, changing the points on what we're calling, Mars, as it were, in relation to each other.
Yeah.
Whereas on Jupiter those change. But what if Mars is just much more consistent? Like if it is some kind of superfluid or something, what if it's just a much more consistent type of like sustained field of some sort?
What would be more consistent than solid rock?
No, I agree that solid rock would also be very consistent.
And not only that, but I would also point to the fact that, and I will be coming in acquiring access to a telescope of this size, but we now have telescopes that can be gotten where you can see like the volcanoes on the surface of Mars. That requires a really large aperture. I'm not sure my telescope is capable of resolving
This has been
those
going on for a
intricate
while, dude.
details, but you would be able to see those volcanoes and canyons and that kind of thing using ground-based observatories.
Why do we get hung up here? Why?
Well, and what would that, you mean, like, what would that look like though? Just like features that would be, you'd somehow be able to tell there's a difference in elevation? Because that seems like a challenging thing to decipher.
No, you would be able to see those changes in elevation, but in order to resolve those details, you would need a very, very large aperture and very, very long focal length. There's a couple telescopes that are within reach.
All right, are you done? I've been
You
waiting
can
to
actually
respond to
get
this.
them.
He's
My
like
God, you are just coping like endlessly. Let people talk, please. You'll have your chance. Anyway, as I was saying before I was rudely interrupted, you can actually purchase telescopes from, like, say, Celestron with enough focal length to resolve those features. And soon we will be acquiring a telescope that can do just that, and I plan on making multiple videos on it. But we also know that this is an object very, very far away because even with the kit we currently have, we were able to measure its distance. So we have surface features, we know its distance, we see that it's rotating. I don't know what else needs to be shown in terms of whether or not it is a planet and whether or not it is rotating.
Yeah. Well, how did you do the distance?
That is a very good question. It required some driving on my part. So what I did was I drove all the way to Colorado, and I had Astronomy Live stay in Florida. Because of the distance between us, we had a baseline that we could work with. So what we did at opposition, that's when Mars is closest to Earth, we both simultaneously took a picture of Mars with the background stars, and we saw that shift. And that shift was caused by the distance between us. We were looking at it from two different perspectives. By knowing the distance between us and knowing the angle at which that we were observing Mars from our respective locations, we could actually get parallax measurements of Mars. And based on those parallax measurements, we were able to figure out the distance to Mars from Earth at that particular moment. We were also then able to look at the angular size of Mars, and because we know the distance and now we know the angular size, we can figure out the actual size of Mars, as in its diameter. And so that observation and that measurement is seen in my video measuring the distance to the sun. Do you want me to post a link to that video as well?
Yes.
If you want to. Sure.
All right, hang on one second. Let me copy and paste that. Did I post it in the right area?
Yeah, you're good.
Yep.
You're in the same country in America, and you think you're getting parallax from stars that are at claimed heliocentric
It's
distance.
not a star.
You've
It's a
got to
planet.
be dreaming.
It's a planet, not a
Whatever you're
star.
looking at, dude, whatever you're looking at, you think you're getting parallax from the same country.
Do you know how big the United States is, sir?
Do you know how far away the planets are, dude?
We had a baseline of over 2,000 miles. Cope harder. My God.
2,000 miles is nothing in the scheme of the distance between us and any other planet in the solar system.
2,000 miles is perfectly acceptable with the resolution that we had at our disposal. Just because you use a shitty P1000 doesn't mean we're limited to the same limitations.
Doesn't that also imply like the diverging plumb lines component? Because you were saying the angle. So the distance, like let's just say for a moment the distance is correct. Let's just, for the moment without contesting the distance. But if over a planar surface, you would both be looking straight up versus, at angles in relation to the center of a sphere. So isn't that something I would suggest that that's assumed. I know you may contest that it's not assumed, but I'm saying like, unless you verified that plumb lines are diverging in some way that was conclusive, isn't it kind of like there's that kind of beginning assumption that's incorporated that you are looking at different angles to it based on
there was no assumption. I just gave a rough overview of what we did. In the video that I posted about measuring the distance to the sun, we actually verify the size and the shape of the Earth in that same exact video. And then we used our own derived values for R, not the one that has been quote unquote given to us. We used our own measurements from start to finish on this one. We were able to utilize the size of Earth within our calculations, but that was with our findings, not anyone else's. And if you want to know how we were able to do that, it was by utilizing the pole star conundrum. So if you take an image of Polaris, or the North Celestial Pole, I should say, and you were to go directly north by a certain distance, and you were to take another observation of the North Celestial Pole again, what you'll see is that the angle of elevation of your telescope changes between those two locations. By knowing the distance you traveled and the angle of elevation change, you can actually figure out what the radius is of the Earth itself. And you can do another thing that's even better. You can plot those exact same points on a flat Earth to see what it gives you, and what it gives you is contradictory answers. So we weren't able to use the flat Earth for this in any way, shape, or form. Otherwise, the answers would be nonsensical.
So how sure are you that Jupiter is a gas giant? And what have you done? Because I've heard you say Jupiter. How sure are you that Jupiter is a gas ball in a vacuum?
What I can tell you is that Jupiter
he's gonna say 100.
I'm going to tell you that Jupiter is covered in a shit ton of clouds, so that's how sure I am. There's a lot of gas on it. A lot of gas.
100%, FC Montreal. He's 100%.
Thank you.
So your answer is because it's covered with clouds. That's why you're sure Jupiter is a gas ball in a vacuum. Do I have you correct?
I don't know what the interior structure of the planet is.
Well, according to your pseudo model, it's a gas ball all the way through. There's no solid surface. Are you aware of that?
That is not the consensus. No. Where are you getting that? No, where are you getting the information that that is the consensus? Because the interior of Jupiter has been hypothesized, but even people who study this shit will tell you that it is largely a mystery.
Well, that's my whole point. So how sure are you that this is a gas ball in a vacuum?
I called it a gas. I call it a gas giant as a naming convention, not as any claim to what the interior of the planet is.
Forget about the interior.
If you're triggered at me calling it a gas giant, I'll just refer to it as Jupiter from now on.
I'm not triggered at all, as you can tell. I'm very calm and precise in my wording. I'll ask you again.
Then allow me to be precise in mine. If you are upset about me calling it a gas giant, I will refer to it as Jupiter going forward. I do not know what the interior structure or whatever of the planet is. I just know it has a fuck ton of clouds, and they change given the observations that I've been able to make on the planet itself.
So again, your answer to my question of how sure you are that Jupiter is a gas ball, regardless of what the center is. It might be a solid or not. That might be in question. How certain are you that that is a gas ball in a vacuum?
The fuck? So regardless what it is in the center. So in
I
one
already
in one
told you
breath.
guys he Montreal. He's gonna be 100%.
No, let
Okay,
him answer. Let's be fair, because first he told me about the clouds. He was certain because there was clouds there. Now
that's
maybe
not
he wants
what I
to
said.
take
Please,
mulligan on it.
please don't put words in my mouth. Please don't put words in my mouth. That's very dishonest.
That's exactly what you said.
No. Would you like me to repeat what I said? Because clearly you weren't listening.
Well, I was listening pretty intensely, but go ahead.
Okay. I need you to listen even harder. Are you ready?
Don't be condescending, dude. Just go ahead.
Then don't be a jackass. All right. You don't be a jackass. I won't be condescending. We'll get through this
We're
together.
resorting to insults. We're resorting to insults now.
Oh no, that wasn't an insult. That was an instruction. So you don't know the difference between insult and instruction.
You said
Okay.
jackass, dude. You don't even know what word you. This is why you're called rhetoric. I'm supposing.
Anyway.
Let's just reset from that. Let's just move forward.
Thank you. Let me be clear. I do not know what the interior structure of the planet is. I don't make a claim as to what the interior structure of the planet is. I called it a gas giant because that's what it's known as a naming convention. I wasn't making a knowledge claim when I called it that. That's just what it's called. Now, could it be that it's gas all the way through? Maybe. Could it be that most of it is gas? Maybe. Could it be that a significant percentage of it is gas? Maybe as well. What I do know that the only thing we see when it comes to surface observations of the planet is just gas. All of it is clouds. There are no terrestrial surface features that can be observed on the planet itself. All we're seeing are clouds, i.e., all we're seeing are gas. Therefore, we call it a gas giant, but that's not to indicate what we believe is at the center of it. Some believe that it may have a solid core. Some believe that it may have a really, really tiny solid core. Some people say it may have a really, really big solid core. I don't know, and for this conversation, I really don't care. So, I call it a gas giant because it's a naming convention, because it has a fuck ton of gas regardless of the percentage. It's a fuck ton regardless.
So are there telescopes here on Earth that can observe the clouds from Earth?
So we call it a gas giant as a naming convention because regardless, it has a lot of gas.
Can you see
Perhaps
the
you
clouds
didn't
on
hear
your
my
telescope?
question. Hold on, bro. Hold on. I asked you of how certain you were. I didn't ask you to give me a diatribe of what you think it is. I asked you how certain are you if that it is a gas ball, regardless of the center, mostly gas ball. How certain are you of that gas ball being in a vacuum? That was the question.
Okay, so clearly you did not understand that I answered your question. So I'm going to try again, and I'm going to speak slower this time.
Don't do it again, man.
Don't do it again. Hang on. He asked the question. He wasn't listening.
Just tell him
We're going to try this one more time.
Just tell him 100%. Fuck.
We're going to try this one more time. If I say I do not know the interior structure of the planet, do you not see how that answers your question of how certain am I? I am not making a claim to certainty. So you asking me how certain am I when I already told you that I'm not making a claim to certainty is... Come on, find the word for me.
Can I just
let me try again. Let me try again.
I just want to ask one thing.
Hold on, bro.
I just want to know.
Like, just give me a minute. Because he clearly doesn't want to answer my question. Regardless of what the center is, regardless of how much gas you think it is, you do think there's some gas, right? The clouds and that? You do think
clouds,
there's some,
yes,
correct?
The clouds are definitely gas, correct.
Okay, so how certain are you that... Bro, why are you doing this, man? Why can't you just wait a minute?
You guys are repeating the same thing over and over again.
Right,
this is great. You two fight. I love this.
Can you just let them finish, Carlos, and then bring your point up? Is that all right? Because they're kind of going back and forth for a minute.
Yeah, but they've been repeating the same thing non-stop 10 times.
Right. Sorry. Well, sometimes we have to exercise some patience and to get to the completion. So, yeah, I think I think SE is saying that regardless of what the center of it might be or what the, I think SE, is it just like general question, like basically like how certain is he that it is a gas giant at the distance they claim and the size and that it's in a vacuum? Like if he,
The vacuum part is my question, which he's avoiding. That is my, he
You never
understands.
asked me about vacuum.
What?
You never asked me about a vacuum.
Are you
He's saying
serious?
how certain of it? How certain are you that it is a gas ball in a vacuum? That's what he was asking.
Again, I don't know what the interior structure is. The only thing I will claim as a certain is that it has a fuck ton of gas on it, at the very least.
He's definitely
See, he's
good at
deflecting.
rhetoric,
He's
you
going to the
guys.
center again. You're
Totally
deflecting.
ignored it.
Oh,
You
my
are
God.
What kind of
deflecting.
answer are you looking for,
vacuum,
SE? Like
Montreal.
SE, are you looking
He's
for an answer
ignoring the vacuum.
like 90% SE, 50%, 100%? Is that what you're asking for? Like a percentage of how certain he is?
Yeah, like how certain, and he's not answering the question. He's going to the center again, whether it's solid or not.
You're
That's
asking me
irrelevant.
for a percentage of something that I don't know, my guy.
Rich,
I don't know the interior structure of the fucking planet.
No, Rich, he doesn't think that a gas ball planet can exist in the vacuum of space. That's
And
what
he
he
should
thinks.
make
He
that
doesn't think there
argument
can be
instead of
an
asking me this
atmosphere.
fucking bullshit. It's like he should
He
make
doesn't think
that
there can be
argument.
an
We can have a
atmosphere next to
conversation about
space.
that.
Can I ask now? Can I ask you now?
Sure.
How
Go
did you
ahead. Go
observe
ahead.
the
It's
Go ahead.
obvious he's skirting the question. Go ahead.
He's not,
Yeah,
dude. He's
cool.
not. How did you observe the clouds from Earth?
How did I observe with a Schmidt-Cassegrain telescope, 8-inch, with a 2.5x
So
Barlow and a Saturn C² camera, which is an IMX 533.
Right.
That's
And
how.
what type of definition is that of the clouds to be sure they are clouds?
What do you mean definition? Are you talking about the motion of it?
Anything like to let you know that it's cloud. What is it that lets you know they're clouds? That's all I have to ask.
Okay.
That's it.
Clouds move, right? So we can see like the cloud patterns move in our own sky, right? You would agree that clouds move, right? And if I'm seeing clouds move on Jupiter, then what other conclusion am I supposed to come to? Basically, if it quacks like clouds, if it flies like clouds, if it fucks like clouds, and what am I supposed to get from that?
Can you show any video or photographic evidence that has been taken from a device, a telescope from Earth of clouds on this so-called planet?
You mean Jupiter? You mean Jupiter?
Yeah. Give us some that's been taken from Earth, not from some telescope floating in space.
Sure. I have a 4 hours and 13 minutes video of Jupiter that I was able to record. It's called Jupiter Live. It's on my YouTube channel. And in that video...
Hey, you want to link that in the chat so we can take a quick little gander, sir?
Sure thing.
Yes, please.
So anyway, as I was saying before, I was rudely interrupted. I have a video.
Calm down, you baby.
I have a video, as I said, of Jupiter. And this video was taken with my own telescope, which I think we would all agree is on Earth. We can accept that, right?
Yeah, post it.
Cool. Excellent. So let's see.
So are you quite confident that anyone that looks at this video is going to say, yeah, that's clouds for sure, 100%? Like anyone?
No, I'm 100% certain that you guys are going to deny it. Don't give me that shit. You guys are going to deny that it's clouds.
You have no idea what it is, dude.
We haven't even seen it
your high
yet.
horse.
It's like we know what the YouTube channel is, we know what everything is, and yet, oh boy.
No, you don't know nothing. You've been told and you believe a story. Quit pretending that
it's fine. If you want to tell yourself that to sleep at night, be my guest.
They're
He made a prediction. You guys won't believe it. Let's see what happens when he shows it.
What's he going to show? He's going to show a picture, regardless of what he shows. He has no idea that they're clouds.
There you go. He just said it. He just said it. Irregardless of what I show. Irregardless of what I show. He just fucking said it.
Being rude, like he said.
He just said it, guys. He just said it. He
Dude,
literally just announced to the world his intellectual dishonesty.
We know who you are. We know what you are, dude.
Yeah, what I am is an amateur astronomer, okay? And that pisses you off to no end.
Listen,
Not at all. You
it's
couldn't
not
even
your
answer my
fault.
simple
Listen,
question.
Essie, I understand it's hard to recognize what a cloud is for you, but like some other people can do it.
Yeah,
No,
you know,
but the
your
thing
medic
is, I
ain't
mean,
gonna
dude, you
work,
guys,
right?
we can try to
Yeah.
find some level of respect for each other. We have different views on it, and yeah, some people don't accept the claims of what the sky is. Now, in terms of the cloud effect, though, like I said, there are other potential explanations for that. Like, yes, one, the globe, the current heliocentric model is one explanation, but like I said before, what if it's like some kind of a gas in a fluid or in a superfluid? You could even have cloud-like effects, but it could actually still be like I said before, like a bubble in a fluid. I'm not trying to debate that or put it forward like as if I'm asserting that because I don't have any way to validate, tangibly the sky, but or objects in the sky, celestial objects. But I'm just saying there are other explanations. It could look cloud-like, but that doesn't mean it actually is a cloud. Because you could have like a water bubble that has like little particulates in it, and it could look kind of like a cloud. You could be like, oh, that looks like a cloud, but it's actually a tiny little water bubble. As an example.
Exactly. You're
That
just not
video in the
certain.
chat yet? Did we
That's
get
how
that
you go
video
about
yet?
explaining. What? Can we talk one at a time? You see how Gio just
Oh,
said,
yes,
well, I
yeah, I
don't
didn't
know, it
mean
could
to.
be this,
I went at
it
the
could
same
be that.
time, but
So, are you saying that it's going to look like there's
Unbelievable.
I
Can
know.
you
I think
have
I
some
was trying to get
decorum,
in,
man?
right?
Can you just
Are you
I
stop
just wanted to
talking
say.
over people?
Well, I'm just
I
not
didn't
sure
mean
if
to
he's
talk over you,
saying.
SC Montreal.
Not
All right,
you, not
Rob,
you.
just stop, just chill for a second. You guys got to go one at a time. So maybe SE and then Rob,
Well, I'm
or
just
vice
wondering
versa.
if SD and what Geo is saying is that there could be a floating sphere of water in space.
No, what Gio was saying is how you
Something.
should be talking. Maybe it's this, maybe it's that. Not being condescending and saying, "Oh, look, it's gas," and whoever doesn't believe it is stupid. That's what I want to say.
Yeah, like
Anyway,
maybe there could be a ball of water floating in space.
a ball of water that looks
Sure.
like that is very
Can
weird.
we
So we
get the
have
fucking
groundwater.
video? You guys, is the video in the chat yet? Red's
not
Rhetoric?
Yeah,
Hang
again,
on.
I wasn't
Gio.
saying it as a debate point to assert it. But I actually said a bubble in a liquid is what I just generally said. But yeah, I'm not claiming that's what it is. I'm just saying that there are other explanations for the optics of what it looks like.
Okay, let me, Gio, if I can just have the floor for a second, because I don't want people to jump down my throat when I show this video. All
Why
right,
don't you just
thank you.
post the video in the chat and let us fucking look at it?
Because I know what to expect. This is my first rodeo. All right, I need to actually put something here.
You keep coming around talking to
So
flat
anyway,
earthers, though.
when it
Good call.
comes to this video, I'm going to post 2 links. Now you may be asking yourself, why am I going to post 2 links? There's a reason for that. So here's link number 1. This is a time lapse of Jupiter that was taken 10/21/23. Okay, I am now going to post a second video of Jupiter that I took myself. The second video of Jupiter, as you can see, is right there. The second one is in black and white because I was using a black and white camera sensor. But what you can do is you can take those 2 videos and you can compare them. And we see that the cloud patterns, while similar, are not the same. There is motion there. They are acting and behaving as clouds do. We have 2 separate observations, 2 separate telescopes looking at the same planet. There's your video.
Okay, let me respond if I may. Nobody here, well, I'll speak for myself. I'm not denying that what you posted shows motion, right? We've seen what appears to be clouds or gas, call it whatever you want. My point is, you cannot be certain of that statement, that they're clouds, and to act like condescending people that are questioning you. That's my point. You don't know for sure what they are. Do you
They look
agree
like
with
clouds, but they look
Yeah,
like clouds.
and you want to know what I am 100% sure of? I'm sure that whatever it is, they're behaving exactly like clouds.
Okay, fair enough, but they are
Good,
not.
good. Let's end on that. Let's end on that. Hi, I'm Red's Rhetoric. Nice to meet you. This was a fantastic conversation.
Why are you interrupting me? The question is, I agreed with you that they do look like clouds, right?
Cool.
But do you agree with my statement that you cannot be certain of that?
Certain of what? That they're clouds?
Yes.
No, I'm not gonna make that argument.
I'll grant you that
you're being disingenuous.
I mean, can you
Essie,
even
I'll
know for
grant you
sure that
that.
it's gas?
Essie, I'll grant you that if you agree that just because the Earth looks flat doesn't mean it is flat.
I'll
Ooh,
agree with that.
actually, that's a good
I will agree with
compromise.
that. You like
Obviously.
that?
That would be a great compromise.
So you agree then, Red, that even though
Yeah,
they might
everyone's
look,
happy to
Just
be
say it,
looking at a
Essie.
mouse
I
right
just
now.
want to hear
why
you
does
say it,
everybody
Essie.
have to throw in at the same time? What's going
I
on,
know,
guys?
man. It's fire.
Let's
Like,
let's try this. Let's try this. How about this? C
how about we let
Montreal.
Esty
Hopefully,
finish
I
his
pronounced
thought?
that correctly. What I will say is this: my confidence on whether or not it is clouds is higher than any other particular option. Am I 100% sure that's clouds? No, I'm not. But what I am saying is that it looks like clouds, it behaves like clouds, it fucks like clouds. So I'm going to lean towards clouds because that's where Occam's razor is cutting.
Okay, we have some progress. All right, we'll accept that.
For that
Essie,
rhetoric.
Essie, are you gonna say it?
I did say it. I agreed with you
No,
when you
no,
said it.
I didn't hear you say just because the Earth looks flat doesn't mean it is flat. I didn't hear you
They
say
want
it.
to hear you say
Well,
it.
I'll say
Esty.
it. I'll say it because I'm not a hypocrite. Just because the Earth looks flat doesn't mean it is flat. And by the way, flat is not a shape.
So they all think the Earth was flat.
Yeah, yeah. But you see, you just admitted something on your own, right? You just said that the Earth looks flat. So thank you
I
for
totally
that.
agree. I'm a glober. I'll say the Earth looks flat from where I stand.
I've always
So,
said that.
so we went over
Not so much
Mars.
from
We
space.
went over Jupiter. What's next on the agenda?
Well, we're not done with Jupiter because I'll say this, right? A ball
Okay,
of
what's next?
gas in a vacuum is physically impossible. And
No, it's not.
well, can you reproduce it then?
Yes, I
Rex?
can. Yes, I can.
Jupiter.
You heard him. So I want to see it. Show me a ball of gas in a vacuum, please.
All right, perfect. So let me go ahead and, by the way, you might have to mute him because I know he's about to interrupt me when I go into this explanation. So I film rocket launches out of Cape Canaveral, Florida, and sometimes these rocket launches happen just before sunrise, which means that as the rocket gets higher, it will start to get illuminated by the sun that is below the horizon. But it's high enough to see over the horizon to see the sun, blah, blah. You know how that works, I'm sure. Well, with the sun illuminating the rocket, it also illuminates the gas coming off of it. Am I allowed to screen share still? Is that still acceptable?
Yeah, sure.
Okay, cool.
That's not what I asked for, right? Like,
Uh,
I don't want to interrupt you.
hang on. I know that you are giddy, but you're going to have to make do. Okay.
I'm not giddy at all. I'm very, very calm.
Very calm. I'm sure you can, and you'll demonstrate that to us all, won't you? So anyway, here is a video I took of the Atlas 5551, and here you can see the gases are being illuminated by the sun. At this point, the rocket is still within Earth's atmosphere. That's why you can see the gases are more contained within this line. So I'm going to hit play real quick. Hang on, there it goes. And as you can see, the rocket is continuing forward. Now, as I progress this video, you will notice something. The gases, as the rocket progresses, gets wider and wider and wider. And the reason why that is because the atmospheric pressure is getting lower and lower and lower. Eventually, the gases get so wide that you can't even see the gases anymore. I'll fast forward to this part of the video where I zoom out where you can see the entire effect. And I will pause it right there. So you can see here where it was lower in altitude, the gases were more contained. Here you can see the gases are more wide. That's because you're seeing a sudden drop in atmospheric pressure. And this rocket is going into a vacuum, and it's doing so without smashing into any dome. Can you imagine such a thing? But that's not all. After main engine cutoff, or otherwise known as MECO, you'll see something. This is fully zoomed in, Nikon P1000, flat earther camera of choice. Watch what happens, boom, boom. See how the gases were expanding outward? You can see that again. Watch, I'll even hit replay for you. Let's see that again. In instant replay. We can see that the gases, are going out. So when the rocket was lower, we saw that the gases were contained thanks to the atmospheric pressure it was within. But as it gets higher and higher and higher, the atmospheric pressure starts to decrease lower and lower and lower and lower. You keep going higher, and eventually you will enter a vacuum. And this is an example. This is a textbook example of a rocket experiencing that drop, which indicates that, yeah, you can have that drop at a very sudden drop with altitude, with enough altitude, without a dome separating the two.
All right, we let you go on and on and on, even though it was not what I requested. Maybe you didn't hear me. Let me ask you again, right? I asked you if you can reproduce a ball of gas in a vacuum, and you told me yes. Then you proceeded to show me a rocket launch. Now, perhaps you didn't understand the question. Did you understand it this time?
Oh, wait. So if I was to remember what we said previously, you were like, hey, can you show me a ball of gas in a vacuum? Because a planet wasn't fucking good enough.
No, reproduce. I'm asking you, maybe it wasn't clear enough. Maybe you didn't understand
Sure.
this.
Give me a
Whoever the
way.
problem was, I'm not done. I'm not done speaking. We let you speak for a long time. Listen to my
Yeah,
question.
SE, I'm sorry. Just
Can
say
you?
demonstrate.
Oh,
Yeah, sorry, SE. I just trying to help you. Just tell him to demonstrate it.
well, I want him to reproduce it, right? To demonstrate it and reproduce it. Not show me
We're
pictures
just
of
gonna ignore
somebody else
everything I just
doing
showed.
something. Can you reproduce a ball of gas in a vacuum?
Can I ask a
Can I
question?
reproduce a ball of gas in the vacuum? Are you talking about like tabletop? Is that what you're asking me to do? You're asking me to simulate Earth's gravity on my table. You want me to simulate Earth's gravity on my tabletop. That's what you're asking me to do.
Nope.
In a bucket.
In a bucket. Oh, okay.
He's
All
asking
right.
you to do something impossible.
Yeah, he's
Just
asking me to
say
do
you
something
can't
that's
do it.
complete
Just
bullshit.
say no, SC. I cannot reproduce.
All right. Hang on. SC, no, I cannot simulate the mass of Earth on my table. Please forgive me. Please. I tried so hard to simulate the mass of the entire fucking planet on my nightstand, and I wasn't able to accomplish that goal. Please forgive me.
Yeah,
So you
explain how
cannot
you're
do
not
it.
setting. Explain how you're not setting up an impossible test. St, go ahead.
No, well, you guys seem to think that you can point to Jupiter and say it's a ball of gas in a vacuum, right?
You want to know
And I'm
why? Because it
telling you-
has the mass of a fucking planet to
can't
work
even let
with.
you finish,
I don't
SC.
have the mass of a
Raging.
fucking planet to work with on my tabletop, you dishonest jackass.
Listen to him spiraling.
Again, you're
Total
insulting.
spiral.
Again, you're getting excited.
That was more
So
of an
you
observation than an insult, but okay.
Listen, dude, just watch your mouth. Be respectful and just say, "Look, I cannot do it."
I'll give you this deal. I'll be respectful to you if you stop giving me tasks that you know
He
for
can't
in
handle
fact
the
are
question,
impossible.
SE, so he rages like a child.
Hey,
Like you asked me, you asked me, hey, can you simulate gas like coalescing into a sphere on your tabletop within a vacuum? No, because I don't have the mass of a planet to work with. And you know that a component, in order for there to be a gas like we see with a planet, is to have a mass of a planet. I don't have the mass of a planet at my disposal. So you asking me to do such a thing indicates one of two things. Either you're ignorant as to what the physics actually dictate, or you knew this was bullshit and you asked me to do it anyway as some sort of gotcha. Which is it, my guy?
Okay, let's see if I can get a sentence out with you interrupting me. Obviously, I know you can't do it because it's against the laws of physics, and I merely want to show the people that you just believe what you've been told, that out there, because it's so massive, there's no way of you to prove it, that
No, I can.
somehow I knew you couldn't do it without interrupting me. I knew it.
Yeah, I know you can do it without lying because I just demonstrated with this video.
Can you? Right?
I just demonstrated with this video. Why are you ignoring the video that I literally just showed you when you say, oh, you can't demonstrate? I just did with this video. It's on YouTube for everyone to see. Everyone can see just how much you're full of shit.
No, you're insulting again. It
No,
must
he's
be
just
because you're
projecting
losing the
SE.
argument. No,
Because
hang on, let me go ahead and provide the evidence that he is full of shit. Hang on.
Flip-flops and
I
says,
love
no, I
this
can't.
guy.
There it is.
Yeah, dude. Your
Post
colors
it
are showing.
in the stream.
SE, did you notice how he flip-flopped? He
have
started by saying,
decorum
yes, I
enough
could
not
do
to
it.
interrupt the person.
Projection.
Too many people talking.
Mic check real quick.
Look, the fact is you've been convinced because you've been told
Alan?
that if a body is large enough, it can amass enough gravity, right, to make a ball in a vacuum. And I'm merely trying to show the people listening that that is not possible. It's just a belief.
Except it's not, because we have evidence that that's actually the case. And the way that we know that it's actually the case is because of things that I've been able to observe myself. Let me be very clear. No one told me this. I went out on my own. I took my camera that you guys told me to buy, I pointed it at something that you guys told me to film, and I filmed it. And it showed what it showed. That wasn't a teacher dictating to the rocket, hey, we gotta try and convince Red's rhetoric that's down there on the ground. Please act in this particular way. The rocket doesn't give a flying fuck, dude. It's gonna do what it does. And I saw it. You telling me to not trust my lying eyes goes against every other flat earther out there that tells me to trust my God-given senses. So which is it, my guy? Am I going to trust my God-given senses, or am I not going to trust my lying eyes? You tell me.
So
what's the correct path forward?
Okay, try to calm down. So your argument is you took a telescope, you pointed it up to this thing called
Camera.
Jupiter, and from... Sorry?
Camera.
Okay, your camera. You took your camera, you pointed it at this thing called Jupiter, and
Rocket.
that convinced you that it's a ball of gas in a vacuum, correct?
No, we're talking about the rocket. You brought up a specific claim that a gas cannot exist next to a vacuum. I presented you evidence of a rocket going through multiple stages of our atmosphere, as indicated by the plume, and it going into a vacuum without smashing into a dome along the way. You don't want to deal with that, and I'm wondering why.
Oh, now you're bringing up domes. I never said anything about rockets. That's what you chose to show, right? So you think
yeah, I chose to show because it directly contradicts your claim. You made a claim that a gas cannot exist next to a vacuum. I provided evidence to show that that was bullshit. What do you have? Did I fake this video?
No, you didn't, but you're assuming. You're affirming.
Okay, so I didn't fake the video, so the video is real. So if the video is real, what is the video showing, if not a sudden drop in atmospheric pressure given altitude?
But that's not what I requested. I requested...
No, you requested something that we all agreed was fucking impossible, because I don't have the mass of a planet at my disposal.
You're insatiable, bro.
Can I ask a question?
Please
And
go
you're
ahead.
dishonest, SE. You're dishonest.
Yeah, thank you for that.
Perfect. Glad we were able to
No
establish
problem.
that.
You can
Anyway.
white knight for your boy, Red. But let this guy ask you.
Quit being fucking dishonest, and then when I won't have to.
Can anyone
Well, I
hear
mean,
me?
the rocket footage is interesting, but if we're gonna be like really kind of strict with like what we can actually verify, can we really verify that? I mean, I saw it is pretty awesome. Like it's amazing, like what they can do with
Thank
that,
you.
and the way that the gas like changed and blew outwards like that. So, I mean, I hear the interpretation of how you're interpreting it, but I guess if we're just gonna be really strict with what we can verify, like, can we really validate that it was actually, even though it matches those patterns, can you really validate that it was actually entering into a vacuum essentially, and that the gases were doing that, or that those effects were happening because of that claim in the first place? You see what I'm saying? Like, can we really know that for sure, or is it still kind of interpreted?
Yes. There's two ways that we can know. There's two ways that we can know. The first way that we can know is the fact that rockets work in general. Now, why is that an important fact to know? Well, it's because rockets have two stages. If you look at a second stage of a rocket, like whether it's a Falcon 9, an Atlas, a Delta, whatever it is, you'll notice that the bell housing is larger, even though the engine itself is the same as any other engine. The reason why they make it that way is because it's vacuum optimized. It would not work very well at sea level. And so the reason that they're designing it like that is to take into account the fact that you're going to have limited atmospheric pressure holding everything down. And also, if you notice, like, for example, with the rocket going up, the gases are free to do whatever they want. So there's only one thing that can really act on them, which is the atmosphere itself. So those are two different points. The third point that I would also give is the fact that we also measured the altitude, size, and speed of the International Space Station. And the space station is going 7 kilometers a second. Any object that would be doing that speed within atmosphere would burn itself to a crisp. And I have that video as well if you want me to post that as well.
Well, maybe
Can anyone
you
hear me?
convinced
I'd like to
yourself,
ask a
but I
question about
assure
this
you,
puzzle.
you didn't convince me or a lot of other people.
I had no delusions that I was going to convince you. In fact, if you remember correctly,
No,
I
you
said
are
that at the
just
very
delusional,
beginning.
though.
I said that I was not going to convince you. I knew that for a fact because you don't want to be convinced.
No, because you just know that was just horrendous.
So if you are actually, if you ever find yourself actually being curious about this stuff and you wish to learn about the observations I've made, the measurements that I've made, and how it points in a particular direction, please come to me. I'll be more than happy to talk to you. I recommend we do so privately. But as of right now, dude, you're not willing to learn. I'm sorry, you're just not.
Nice try.
That's false.
Listen, SE, this guy Rick's been trying to ask a question and people keep talking over him.
Fair enough. Yeah, let's give him a chance. Fair enough.
I just want to ask like a couple of questions. It's like just a really short thing. It's about this exact topic that you're talking about. So, do you agree that like the downward vector that we experience, some call it gravity, whatever, acts exactly like a force? Like, it acts like a force. Do we agree on that?
Who are you asking?
You.
That it acts like a force.
Not saying,
for argument's sake, I'll say yes, but obviously we know it's not a force because it's been superseded by the fabric of space-time, but I'll play along. Go ahead.
But it has the attributes of a force. It acts like a force does, right?
Well, like I said, I'll play along with your scenario. Go ahead.
It doesn't act like a force. Okay.
No, because gases go every direction.
Yeah, exactly. Yeah.
Well, that's not true, but
no, I guess it is true. Gases go in every direction.
I'm more than happy to get back to that.
No force pulling it down.
More than happy to get back to that. It's not true, and I can prove it. But for now, let's go with what SE said, which is that they do act like a force. It does act like a force. Okay, so if that acts like a force,
just for argument's sake, he's saying yes.
Yeah, I'm not agreeing with you. I just want to see where you're going, right? I reserve the right to change my mind to correct. I'm playing along with you, right?
I just didn't want to waste time.
Yeah,
I can
here.
weigh air in a scuba tank, which proves that the air in the scuba tank is pushing down harder when you fill the scuba tank up. It pushes down harder than when the scuba tank is not filled up, because the gas inside it is pushing down harder. That is proof.
Well, no, the air is pushing at all directions in the scuba tank.
No, it's pushing down. The more air in there, it's pushing down harder because the scuba tank weighs more.
No.
Oh, you're saying as related to... Okay, go ahead. No, let's get this thing. Let's see where it's leading. Let's be fair.
I can literally get a scuba tank for you. I can empty it. I can weigh it. I can fill it. And I can video filling it, watching the weight go up.
You're going to say the more air, the more it weighs, therefore pushing down on the scale. That's where you're going, right?
Is it not pushing down on the scale? How else is weight measured?
Go ahead. Yeah, okay. All right. I want to see where you're going. Go ahead.
So if we agree that gases are impacted by this downward vector, which is supported by the fact that I can weigh a scuba tank, I can literally do this live on stream if you're interested.
Right, but you do realize it's in a container, right? Had the air that you put in there not been in the container, what happened to it?
Well, the question is whether or not it is affected by the downward vector. And it is, because I can weigh it.
But only because you have it in a container.
No,
right?
It's affected, but that's irrelevant. The fact that it's affected by the downward vector is only possible if it's affected by the downward vector. It doesn't matter whether it's in a container or not in a container. It's only possible for it to weigh more if it's affected by the downward vector.
Well, it does matter. You can't say it doesn't matter because you're putting it in a container. That's why you said a scuba tank.
Hey, Rick,
are you suggesting that it magically has weight once it goes inside of a container? It just magically decides that it has weight?
Hey, Rick.
It's contained. It's contained.
Hey, Rick, if I may, why don't you ask me these questions? Just pretend I'm the flat earther for half a second so we can actually get through this.
Okay.
Yeah,
Well,
so
I think
no.
we've essentially agreed that scuba tanks weigh more. Whether you
Yes.
say it's because it's in a
I will
container
say
is irrelevant.
a scuba tank objectively weighs more when you put gas in it.
Yeah, and I mean, I can literally do this on stream, so it's not really up for debate. Now, I appreciate that. Now, okay, so we've established that forces act on gas.
Yes.
Now, as we go higher in the atmosphere, we know, and you can test this at home, and I've done it. Go up a big hill, get a barometer, test the pressure. We can test this. Super simple.
Or a
Right,
bag
20
of
bucks.
Lay's.
Yeah, literally. Yeah, literally. Well, I mean, a barometer is like 20 bucks. You can get a fishing barometer on eBay for 20 bucks. You can just go up and down a hill and test it. So we know that the pressure gets lower as the higher you go, and we know that the downward vector affects gases because they're affected when they're in a scuba tank, and I can weigh it. So these are two things we know. We also know that if you get uranium hexafluoride and you spin it in a centrifuge very quickly, it creates uranium hexafluoride at the outside of the centrifuge and a very, very near vacuum at the inside of the centrifuge. So we know that when you have a force acting on a gas, you can have a gas next to a vacuum and it doesn't infinitely expand into it. So we've established two things. We've established that gases are affected by a downward vector because otherwise scuba tanks wouldn't weigh more full. We've established that the closer you get to the surface, the denser the air gets. I've also established that if you have a force acting on a gas and the force is strong enough, that you will have a vacuum next to a gas, and it will not fill the size, or it will not fill the space available indefinitely if there is sufficient force acting on it.
And it also
There's
shows
so
that my
many
footage is
assertions
consistent.
and zero demonstration. Please just demonstrate it because you have all these claims.
Trigger.
All right, so
What would you like me
source
to
of
demonstrate?
something creates
I
like
obviously
gravitational pull.
can't demonstrate
Okay,
it.
so something with great mass should attract gas. All right, is that always the case?
What are you asking me to demonstrate? Because I obviously can't
Is
demonstrate
it
centrifuge.
always the case? Are you not following me?
He wants you to
what was-
create a new planet outside of Earth and then show that
No, not a
gas is
planet. You
attracted
should be
to
able to
it.
do this. You should be able to replicate this at a very small scale.
How so?
There's
How
gas.
would I replicate the mass of a planet
hang on.
small scale?
Or are you guys confused in talking about density? When
You're the one
this can be
confused.
replicated.
You're the one
Stop,
confused,
hang on.
Trigger.
Because it sounds like
This
you're
can be
talking
this
about
can be
density when
replicated.
it comes to gas, because you're like, all gas travels down. Well, except for
No,
the
that's
ones
not what I
that
said.
don't.
This can be
Yeah,
replicated
that's
at a small
exactly
scale
what you
by
said. You said
centrifuging
gas
uranium
travels
hexafluoride.
down.
No, this can be replicated by centrifuging uranium hexafluoride. It's a very heavy gas, so it doesn't need to be centrifuged as quickly as other gases would to achieve the same thing. But it can be done. And this is how, I can't demonstrate it. You may have seen what's happened in Iran recently because they tried to demonstrate it. It wouldn't go well if I tried to demonstrate it. But it can be done, and it has been done, and it's regularly done
Dude,
in
that is
laboratories.
so lame.
It's
And
how
You're like
uranium
the war in
it's
Iran is because of this.
it's literally how uranium is purified into, or is converted into nuclear.
So basically, in order for me to demonstrate it to the flat Earth standard, I would need to be possibly breaking international law. Excellent.
Well, no, it's the point. My point
So
is that
unfalsifiable.
I
can't check
sign me the
myself. You
fuck
just
up.
have to trust me, bro. That's
In my opinion, it was easier just to film rockets at
Promise.
this point.
No, my point is, I'm not asking you to do this. This is done regularly, and there's scientific papers on it all over the place. My point is that you can do it, and it does demonstrate that a force will create.
Your point you just made
next
is
to a
you
vacuum.
can't do it without going to jail. That's the
I
point
can't
you
do
just
it.
made.
Yeah, but
and now
I
you're
can't do
saying
it.
you can do it. Well, no,
I
actually, I
said it
can't,
can be
according
done.
to you.
It can be
And
done.
my point is that you don't have to do it.
I can't do it. You can demonstrate it. You can't
I
demonstrate
can
it.
demonstrate it. I just did.
I understand it.
But we know we already know that gas is affected by a downward vector.
No, we don't.
Yes, we do.
Because not all gas is.
So if you say gas is not affected by a downward
affected
vector,
by what seems to be density.
No, it's not.
Density.
Okay, so how do you explain the non-downward bias of helium?
Wait a minute. Are you saying that the reason
is that
why
like anti-gravity gas?
Hang on. I love this. Just let me cook here for a second.
Well, you said
Are you saying that
gas
the
has a
reason why?
downward
Are you saying the
bias.
reason why things fall is because of
I'm
density?
saying what I said. I don't need you to reframe my argument so you can argue against yourself.
Then say it again. Only this time with your whole chest. Are you saying that the reason why things fall is because of density?
It's like, dude, listen to your voice, and you're gonna criticize mine. You squeal when you talk.
Answer the fucking question, Rigger.
Okay, so I'm sorry. Was I not clear enough for you? So let me go ahead and try this again. Are you saying that things fall because of density? Is that what you're saying?
No. That's
okay.
not what I'm saying.
Okay. Then you're talking about something else. Then you're talking about something else.
Because you seem extremely confused. What you're saying is gravity causes gas to fall down. Okay. I say, well, that doesn't seem to be the case because not all gas falls down. Could you explain to me why helium has an anti-gravity effect? And
helium does not have an anti-gravity effect.
Okay, so it doesn't like align with your assertion that all like gas.
Are you wait a minute? Are you saying that you don't understand the concept of
I'm
floating?
saying what I said. I don't need you to.
Okay, I understand. So you don't understand the concept of floating. So allow me to explain it to you in a way that even you would understand. So if I am in a gravity vector,
I don't need you to.
If I'm in a gravity vector, you're going to learn. It's okay. It's okay. I understand. I understand you're triggered right now.
We gotta go one at a time.
I will explain it to you.
There's a downward vector for
If
gas.
you have if you are in a density gradient and I have heavy stuff, if I have heavy stuff, it's going to go lower than the lighter stuff.
To this guy. I was talking to the other guy who's making all the assertions.
Rigger, just stop, dude. Just stop. Just stop interrupting, bro.
So
Just
why does
hold on, you guys. Just hold on, Rigger. I just muted you for. All right, he left, dude. That's just all right. Just go ahead, Reds.
So
he wasn't even talking to Reds though. Why is Reds getting in when Rick was the one that had the question? Nobody was talking to Rick's.
So why does on this whole idea, why does an anvil float in mercury? I mean, it's the same thing. Mercury.
Yeah, that's exactly what I was saying.
Why does it float?
It's not anti-gravity. It's just.
Why does it float?
Why? Because it's lighter. What do you mean? Why does it float?
It's less dense than the medium.
Mercury. Mercury is
less dense than it's less dense than the medium.
So the anvil would be less dense than the mercury.
Yeah, but that's not the cause of things falling down because things fall down in a vacuum.
Correct. Exactly, and that's why I was going to ask him the question.
Less medium. Amazing.
So I was, and that's exactly.
So
that's exactly why I was going to say this, is that if you believe that density is the reason that things fall, then you would have to explain why things also fall in a vacuum.
Because there's less medium? Okay.
So why do all things fall the same speed in a vacuum?
Exactly.
They fall at the same speed? That's incorrect.
No, it's not.
It's been demonstrated a million times.
I mean, there's like videos.
Show demonstrations.
Feather and bowling ball, my friend. Feather and bowling ball.
Yeah, Dave, you even see when it doesn't let it go at the same time. So yeah.
No, they did let it go at the same time. You're just scoping at
come back. Come back again with something else because we've seen.
Elbow,
he's
right about this. Wait, hold on, Elbow. How much later do you think?
No,
hold on, Elbow.
You think me?
How much later do you think they released the feather for the bowling ball?
5+ years have not seen that video, not once.
Okay, Elbow. How much later do you think they released the bowling ball to get them to land at the same time?
Doesn't matter. It wasn't at the same time.
It does matter.
It does matter. It was exactly at the same time.
It was not exactly at the same time.
Did they land at exactly the same time?
I would say so. I would say they landed at the same time.
I'm curious. I mean, if you're saying it's not exactly the same time, I'd like to know the timing difference. What was the timing difference?
Even if there were millisecond timing errors, it still shows that the feather and the bowling ball dropped at the same rate.
If it's milliseconds, so if I don't let it go at the same time, but they fall at the same time, therefore they all fall at the same time. It's ridiculous answer.
Let's go ahead and do this. Since I have the ability to screen share, we can actually take a look for ourselves. That sounds like an amazing idea. So let's do that. So what I'm going to do is I am going to screen share, and we're going to do this frame by frame, and we're going to see just how much of a delay there was between the bowling ball and the feather. Place your bets. Let's find out. Oh wait, hang on. Let's go back. So 1 frame, 2 frames, 3 frames, 4 frames, 5. Oh, Look at that. They started moving at exactly the same fucking frame.
It might be half a frame difference, man.
Look at that. Look at that. Hang on. All right. So that's 1 frame, 2 frames. They're both still not moving. 3 frames. Oh, look, they were like go at exactly the same time. Cope harder, my guy. Holy shit.
No, Rick might be right. We need double the frames to really be able
do you
to
have
tell.
you have a camera filming this camera?
Oh man, they were literally dropped within the same frame. That is excellent.
That's so good, man.
It is good. It is good, especially when you can see like, oh no, they were totally delayed. No, the fuck they weren't. That's Cope.
So I wonder, since we watched that, Elbow, would you concede that they are released at the same time?
No, nothing to say
I
now.
wasn't watching this video. I tried to click it, but he was already gone.
Well, everyone else watched it, man. That's okay. We all know.
Of course you were.
I'm having so much fun right now. That's great.
Is SE still here or is he gone?
The thing is, yeah, okay, fine, that one. But again, it's only an average. It's not really the same time.
Average, Jesus Christ.
Yeah, because
So
they don't
hold on.
times fall at the same time. How many times was this done?
Elbow, 1 second. Do you admit
Hold
that you
on,
were
how many
wrong?
times was this done?
Do you admit that you were wrong
How
then,
many
motherfucker?
times was it fucking done?
Were you wrong?
Once. Who cares? It's only got to be done once.
Just say you were wrong and we can move on. It's fine.
So an experiment only gets done once? Wow.
It's not an experiment, man. It's a video for YouTube. No one's writing a paper on this.
Oh god. Someone did write a paper on it, but it's like really, really old at this point in yesterday's news.
So then he's wrong then. Okay, appreciate it.
As far as
Does anyone, just before we go on to a new topic, does anyone doubt the fact that air weighs more in a scuba tank? Is that a doubt by anyone?
Well, there probably are
Haven't
people
we been through this before? It's like saying, I brought my barbecue container empty, it weighed a certain amount. Then when I went to the gas station and filled it, it weighed more. What argument do you think you're making there?
That means air has weight.
I mean, it has weight. That's the only argument.
Let me give just a simple illustration. Say you sold something on eBay and you don't have a scale handy. Are you contesting the fact that you can't weigh yourself on like or like a scale that will weigh something that's like, I don't know, 2 pounds? And are you suggesting that you can't step onto a scale that you might have in your bathroom and it tells you weigh whatever, 100 pounds, 150 pounds. And then you get on with the box and then the box doesn't increase. And so that you can just assume that that box also has weight?
What kind of a gaslighting question is that? Who said anything about
Well,
that?
you can first of all, what you can do is you can weigh a scuba tank on the boat, for instance, before you go into the water. You can go down, you can look at fish, take pictures, whatever, come back up. You can then again weigh the same scuba tank. And guess what? It's going to weigh less. Therefore, the oxygen that was inside the scuba tank had weight. Do you agree?
Well,
yeah,
I don't
but you
think
don't see
anybody's
the irony of your
contesting it.
statement that you have
Nobody's
to put
contesting that.
the air
Sorry.
in a scuba tank. Do you not see the irony of your question?
No, explain it.
You're putting it in a container.
But that's what's I don't see the problem with that.
I mean, isn't it obvious?
Wasn't SE's question about having a ball of gas in a
Well,
vacuum?
what properties?
Yes.
Properties change? What properties of the oxygen change when it's in a container versus it being outside of a container?
The containment.
It's contained, bro.
What properties?
What properties of the
gas
oxygen? I'm not talking about the conditions of where the
How could you even
chemical
measure the
is.
properties of it without it being contained in something? It's impossible to
Well,
get around.
let me pose a slightly different scenario. Let's say I have a tank. This will be good. Let's say I have a tank I'm just going to open the valve and let it fill to room temperature. I'll close the valve. I'll weigh that. Then I'll get a vacuum and I'll suck as much air as I can out, and I'll put the cap back on. So now I have a vacuum, and I'm going to weigh that. Do you guys think that those will weigh different?
Yeah.
What do you think, SC?
Yeah, probably. I mean, no one's arguing that weight change happens when you have a tank filled versus not filled. That's not his argument, guys.
I'm not talking about filled. I'm just saying I'm filling it with ambient air. Like basically
you're
what it's
changing
showing is
the subject. You're just coming in, Pfinky, here trying to disrupt the convo.
no, I'm not. This is the same
I'm not talking
subject.
about that.
I was
No, we
listening
are. We're
in
talking
on
about
YouTube
tanks, the weight of tanks.
and he asked Reds. I don't know if Reds is still here or McToon or John or whatever you want to go by. He asked him, "Can you please demonstrate?" He said, "Yeah, I could demonstrate it right now. A ball of gas in a vacuum proceeds to show a rocket launch that is totally non sequitur and a red herring."
No, he showed gas next to a vacuum. That's what he showed.
And then a breath moment later, he said, "No, I can't do it." But
He said
more
he can't
color-free.
create a ball of gas on
Yeah,
his
Reds,
desk.
you try to basically Mott and Bailey his argument, try to make it something that he
Can
wasn't
you
actually making
define
an
a Mott
argument
and
against.
Bailey for me, please? Because I
where
don't
you
think it
change
means
the
what you think it
argument,
means.
where you change the argument to something that's easily defendable or easily arguing, or you can easily argue against it.
No, Amont and Bailey would be retreating to a different argument altogether,
Yeah, that's
whereas
what he
you get off of topic. You missed that part. We were on topic. The topic was gas next to a vacuum. I showed an example of gas existing next to a vacuum. Therefore, your Mott and Bailey accusation has been falsified. Thank you for playing.
In a vacuum. He said a ball of gas.
You got to try harder, my guy.
Ball of gas in a vacuum.
The original request was for gas next to a vacuum, by the way.
The original request was for gas next to a vacuum,
No.
and so he was trying to say, "Hey, can you demonstrate it? Can you demonstrate it?" I said, "Yes, I can," which I did, which he hasn't been able to refute. And then he said, "Oh no, let me be more clear. Since you completely whipped my ass on this one, I need to make the task impossible. I want you to simulate gas coalescing into a ball on my tabletop, as if to say that I should be able to mimic the mass of Earth on my fucking tabletop."
That's correct.
Dude, okay.
Gaslighting. I hope nobody has matches around. What a gaslight.
Yeah, you're good.
So I would actually say that he did kind of like the reverse Mott and Bailey on that one.
I'm going to defend him right here because that wasn't his argument. He asked you for a demonstration of a ball of gas because you guys were talking about Jupiter, right? Right?
And Jupiter's a planet the size of a planet.
So then what did he ask? Okay, so then what did he ask you? Can you demonstrate a ball of gas inside of a vacuum? Can you read?
You're right. You're right. The first thing,
yes,
the first
yes,
thing
I
they
can.
showed
Yes.
was the ball of gas in a vacuum, which is Jupiter. Since that's illegal, apparently, then he was resorted to, oh, these are things that I've done myself and that I can show you. That actually support my
It's just
argument.
an interpretation. It's an interpretation. This is what SE was saying.
So now it's an interpretation and not a Mott and Bailey.
You're going to keep interrupting.
They can't even let you finish. They were just interrupting SE as well.
Yeah, SE said that that's your guys' interpretation, but can you actually physically demonstrate a ball of gas inside of a vacuum in order to substantiate that interpretation? You guys say no, it's impossible. I can't replicate a planet here on my tabletop. Therefore, that means it's unfalsifiable. You have an unfalsifiable interpretation.
No, it can be falsified. You're completely wrong on that.
How can you falsify it?
Simple. All I have to do is film a rocket launch. That's how I can falsify it. If the gases operate in a way that would indicate a sudden drop in pressure with altitude, that shows one conclusion is correct. If it doesn't do that, that shows that a different conclusion is correct, thus making the thing falsifiable literally by definition. How are you not getting this?
Wait.
Oh, you got nothing to say now? Cool.
Could you repeat that? Sorry, I was reading something. Repeat it.
Okay. The definition of falsifiable, you know what that is, right? That means if something happens that would negate the thing, right? So okay, cool. So if I see a rocket launch and the gases are behaving in a way that would indicate a drop in pressure, that would lean toward one conclusion being correct. If I see them not doing that, that would lean to the different conclusion. That would lean to the different conclusion. So that means that the claim is actually falsifiable, despite your claim of it not being falsifiable.
You're literally not making it analogous, dude. You're bringing up a rocket. No one talked about a fucking rocket, dude.
No, did you come in here late? Okay,
a ball of gas in a vacuum.
I didn't come in here late. I've been listening the whole time on YouTube. And
So what did I say? What did I say about the gases of the rocket? What did I say about the gases of the rocket if you did not come in here late? That with the rising in altitude, what should the gases do if we're correct?
Yeah, you basically made it a totally separate point. Yeah, I watched the video.
So you don't know. So you weren't paying attention. Okay,
no, I did.
so
I watched the whole thing. Like I said, that wasn't the original
then
argument.
answer the
basically
question. If the gases
his
are being
argument.
expelled from the rocket, if the gases are being expelled from the rocket, and we, the globies, are correct, what behavior should we expect to see?
That the gas should basically, let me see. I don't. Depending on how high you are, right? Like, so it should disperse from like the epicenter of like where your rocket is. So it should go in all directions, right?
It go in all directions. Now, what did we actually see?
A gradual
dispersion in all directions, right? We saw that, right?
Yeah. Oh yeah.
Okay. Okay. So
that's fine.
Okay. Cool. So we saw something. So we would all agree that if we didn't see that, then it would be falsified.
No, but that's not your. This is literally a totally separate argument. Like,
no, it isn't. It's not a separate argument.
Okay, tell me what does that have to do with balls of gas in a vacuum?
Because here's the thing. The claim is that you cannot have gas next to a vacuum at all, regardless if it's on a ball or not. And we're saying here that actually you can have gases next to a vacuum, which means if you can have gases next to a vacuum, you can sure as shit have balls of gases next to a vacuum, as long as there's sufficient force to hold the gas together.
You're making a leap.
No, I'm not. I'm saying is that if it's possible, then it is possible. It is literally a tautology.
No, you're making a leap of logic.
Beasticles, let me see if I can provide a way forward. Beasticles, you agree that there's a gradient in the atmosphere, right? You just yeah, you just say that it's something other than gravity, right?
It's something. What do you mean other than gravity? What's
gravity
the cause of the pressure gradient? Is that what you're asking?
Gravity is not. Yeah, gravity is not the cause of the pressure gradient.
You can only have pressure, right, when you have gas exerting force on the walls of its container, essentially. Gas pressure, right?
Why is that the case?
You have to have it contained. You guys claim that the container is gravity.
No, but it has to be contained, yes.
Right?
But
Am I right? Is that the steel man of the globe argument, right? You guys claim that. Is it a straw man, Rick? No. Reds, yes, correct, Rick, please.
No. Container is not the same as containment.
Thank you. Thank you for that distinction. That is actually very, very important. So, yes, they are contained, but there isn't like a solid dome barrier or some bullshit.
I didn't say that. I just said container.
No, there is no container. It is contained.
Okay. It's contained by such gravity, okay?
By gravity, correct. Yes. That would be a steel man of it.
You could say it's acting as a container. That would be fair too.
Okay, so if gravity is the container, okay, so that means you should have a dividing line, aka the Kármán line, that's arbitrary between the vacuum of space or the nearly perfect vacuum of space versus
not at all.
The air. Okay, so then how?
It's a gradual change. It's a gradual change.
But that goes against the the second law of thermodynamics.
No, it doesn't. The second no, it doesn't. I gotta sell you a shirt that says asking about the second law of thermodynamics. No,
doesn't high pressure go to low pressure?
Yeah, but here's the thing: in a closed system. Here's the thing: the Earth isn't a closed system, my guy, and there's other forces in play, i.e., gravity. So when we have our atmosphere, what you see, and which can be demonstrated, is that as you get higher and higher and higher, the atmosphere objectively gets thinner and thinner and thinner. If you were to keep going all the way to extremes, eventually you will find yourself in an environment where you could safely call it a vacuum. Now, where you want to put that bar? Some people say, 10 to the negative 17, whatever the fuck, it doesn't matter. You can define it however you want, but eventually you will find yourself in an environment where you will fucking die if you don't have a spacesuit.
But this is the point, Reds. This is the thing that doesn't make sense to most people, okay? Is that the fact that you are also moving at breakneck speeds in the space that is supposedly a near perfect vacuum. Okay? So
what's wrong with that?
Okay, so how do you not have loss of this quote unquote pressurized system? If it's just being contained by gravity, that's the only
loss by what? Lost by what?
All right, you're moving 67,000 miles per hour.
Oh, now you're talking about orbits. Okay.
Well, this is important, right? Wouldn't you expect to be some type of like comet kind of a trail behind Earth?
No.
Why not?
Why would we?
Because you're
comet trails aren't made up of gas, for a
you're
start.
supposedly also losing air gradually, correct?
Any sort of gradual would be far too gradual for there to be a tail. We're not a comet. We're a planet, and we are more massive than comets. We are more massive than comets. Comets can lose material very easily because they are puny in comparison.
Comparison to what?
A planet. A fucking planet.
So you think the size of the planet that
It
determines
matters,
if there's
yes,
a tail?
absolutely. The size of the planet definitely matters. Absolutely 110%.
Yeah. How do you know that?
So well, let's just. I'm just trying to do an internal critique here. So I just want to make sure I steelman it properly. All right. So
okay.
If that's the case, right? If you have, like, for example, your rocket video. Let's just go there.
Mm-hmm. Yes.
Right. So you have gas that basically is dispersing behind it. Now gradually it starts to disperse, from all directions. Okay.
Yeah, more and more as altitude is increased.
Right. So now that it's separated from the rocket, that gas, why is that gas not being pulled down the Earth by Earth's gravity?
What are you talking about? Because it's already up in the atmosphere. It becomes mixed with the
right?
media.
It should be being pulled down, right? That's exactly what an orbit is. It's like a free fall towards Earth.
What would make it pull it down any faster than any other gas?
Its mass.
Yeah, it will eventually come down lower, but who's to say it should be careening towards the ground as if it was a rock?
Its mass.
It has the mass of a rock?
No, but its
That's
mass
news to
is
me.
significantly lower than the mass of the Earth. So according to
It's significantly lower than a rock. It's going to be wispy. It's going to be wispy. Gas is wispy. It's not a solid rock. So it's not. We shouldn't expect the gas to be careening down to Earth as if it was, a bullet.
Why not?
Because it's a gas, not a solid.
So then you're invoking another force other than gravity that's making it wispy and not actually travel towards the center of the ball, right?
You mean the physical property that gas is a gas? Gas, the physical property of gas is not part of the conspiracy?
Or the relative density of what the gas is in?
The relative density, what?
Of the medium? Yeah, the relative density.
If I have, okay, let's try this a different way. I have an object in my hand, okay? I am going to drop this object. Let's see what happens. Or not drop it. I'm just going to let it go. We'll see what happens. Okay, so that fell very, very, very fast. Okay, so I'm now going to catch air in my hand. Let's try it. All right, I have a fistful of it. I'm going to let go and see what happens. Why did that happen in your paradigm?
A fistful of air?
Yeah, so I dropped this. I dropped this object, and this object is not air; it's a solid object. I'm gonna let it go. Let's see what happens.
Yeah, the relative density of that object.
Okay, so that
of the medium called air, right?
So I'm now going to
by it, right?
I'm now gonna get a fistful of air. I'm gonna let it go. Let's see what happens, guys. So drum roll, please.
Oh, what happens when you release a fistful of air in underwater?
What happened there?
Yeah, what happens when you underwater, bro?
Yeah, so it seems to me that air being wispy doesn't immediately careen towards the fucking ground. So there's the answer to your question, I guess.
But it immediately finds equilibrium with its medium.
Because you're releasing gas and a whole bunch of other gas. Congratulations.
By the way, I went through the video with the balloon, and the feather definitely gets released before the balloon. I mean the bowling ball.
It just doesn't. So
it does. I just went through frame by frame, and you can see the pin. You can see the pin on both sides. The feather gets released, and then half a second later, the bowling ball gets released.
That's just
half a second later.
Doesn't matter.
How many frames is that?
10,000 milliseconds.
How many frames a second is that?
Doesn't matter. It gets released before. They're not both.
No half a second.
Okay, all right, hang on. I'm gonna straight up call bullshit on this right now. Let's watch it together. Let's watch it together, shall we?
Did not get
so, 1 frame, 2 frame, 3 frame, 4 frame, 5, 6, 7, 8, 9, 10,
half
11,
a frame
12,
or milliframe.
13.
It doesn't matter. It does get released one before the other.
Let's see. Let's look at this together. 1 frame, 2 frame, 3 frame, 4. Oh, look at that. It gets released on the same exact fucking frame. We can see it right here,
You can
right
see the
here.
pin. The pin.
Look at that. Look at when they start moving. Look at when they start moving. Look at the amount of cope we
I got
have.
screenshots if you want to see
It's
the
a bad,
actual
it's a
metal
bad
pin.
argument, Elbow.
Look
I
at
don't care,
that.
dude. Well, they're saying they both got released at the same time. They didn't get both
Look at
released
that.
at the
Got
same time.
released at
It's fucking
exactly the
bullshit.
same time because
It's
that's when they
fucking
started
bullshit.
moving at the exact same time. Look at that. Amazing.
Amazing, because guess what? The feather holds up a little bit longer because of the little pressure there is inside. More.
Boop, boop, boop. Literally, when you start having to go frame by frame, we can say for certain that they were released at exactly the same time, and any delay between them would be insufficient to save your bullshit story.
I'll post the screenshots of you seeing both pins in, one pin being released, the other pin still being in, and then the other pin being released.
Look at that.
To quote Beasticles, it's a bad argument, Elba.
Yeah.
I don't understand what Beasticles says. You're saying they both got released at the same time when they didn't.
This is a really unproductive discussion. Can I ask Beasticles
I don't
something?
care what you're saying. You're saying they both got released at the same time, which they weren't.
Okay. Beasticles, I got a question for you. I got a question.
Is that true? Did Reds lie or did Rick lie though? Who was
Elbow, I
lying
want you to
about
stop using this argument. Therefore, what? Let's say it doesn't get released at the same time. Therefore,
so they're not going down at the same time.
Okay.
If you release one before the other and they both fall at the same time, that means that you had to time a little bit more hold time so they could both fall, so they could make it look like they fall at the same time.
Except that's literally not what we saw in the video, and anyone
Their
can see
point
it.
is that they both fall at the same time, which they don't
Yep.
if they're releasing one before the other.
Which they released at exactly the same time, literally on the same frame. Yes, they did. You're just full of shit, objectively.
I mean, you're just sitting there watching it on video. You're watching in the frame them releasing at the same time.
And zoomed in on the video and seen one piece.
They started moving at exactly the same time. They started moving at exactly the same time.
Okay, so one was released. It takes a second to go because of
They started moving at exactly the same time. That means they were released at the same time.
Stop interrupting, please.
Let's just have. Can Elbow share his screen and show us? Like, I want to see it.
Yeah, maybe he can show us
post a screenshot.
what he's talking about. I don't want a screenshot.
Show the video. Show the video. Yeah.
Roll it.
I mean, if you dropped a bowling ball in a feather that's not in a vacuum, you know what I mean?
Elbow's argument is simply that just because they start moving at the same time doesn't mean they were released at the same time. Is that right, Elbow?
Yep.
Yeah, it's irrelevant though.
Therefore,
can we? Yeah, it's irrelevant. Hey, Beasticles, I got a question. So if you said something before about gases moving to equilibrium, and then if you release a gas, it's gonna move to equilibrium. Is that right? Is that what you said?
Hold on, wait.
You have a gas without a container?
Oh, that's interesting. It is.
PC, I remember him saying
much.
something in response to Reds was like gas. Red said something like the mass is not attracted to Earth, and then wispy gas.
I was gonna ask.
There's no reason for it to go down.
I was gonna ask, do you actually subscribe to mass attracting mass, Reds?
Yes.
And do you also subscribe to space-time curvature?
I don't know about the space-time curvature thing. I haven't seen it myself, but it is the most coherent thing I've seen so far.
I mean, one says gravity's a force, one says gravity's a pseudo-force. So I mean, which one?
Cool. I don't care. All I know is that gravity behaves like a force, and that's all I care about.
Yeah, so I posted the screenshots. One screenshot, both pins are in. One screenshot, one pin's in, the other one's still in, and the third one has both pins being out.
I mean,
doesn't matter.
Yeah, it doesn't.
So we talk about one frame difference. Is that what you're talking about?
It doesn't matter. It's not
either
at the
way.
same
If
time.
it wasn't in a vacuum, it wouldn't follow the same speed. It's pretty close, dude. It doesn't
Okay, bro. If you would have released both at the same time, that means one would have been further down than the other. That means one had to be held for half a second, or I don't care if it's milliseconds, bro. It's because they wouldn't fall at the same time, bro.
The cope is just excruciating.
No, your cope is in
like we can literally watch it at the same time
when they won't.
Literally start moving within the same frame, but that's not good enough for you.
Were they not released at the same time, or were they released at the same time?
They were released at hang on. Let me be clear about this. They were released at exactly the same time, within the same fucking frame.
Look at
same
that.
frame. We just saw it and watched it together.
Look at the fucking screenshots, bro. One was the pin
I'll
was
be
already
better.
released.
Let's
the other
watch
one
the
wasn't.
fucking video together, bro. Let's watch the fucking video together, bro.
You're watching the video.
All right, here we go. Let's go ahead one more time, and this is the last time we'll go. So elbow demonstration of you being wrong.
Zoomed into the pins.
All right, this
Look at
is
that.
horrible.
And boom. Started moving at exactly the same frame.
But were they released at the
We
same time?
are done with this conversation.
Were
You've been
they released at
debunked.
the
We're
same
moving
time?
on.
Because they weren't.
We're moving on because you can cope. That's fine, but we're moving on. Anyway, yes, I do. I do subscribe. Yes, I do. Yes, I do subscribe to mass attracting mass. What is your
I
point?
love how y'all keep speaking. If y'all gonna keep talking over me, I'm gonna keep talking over y'all.
What?
And they're gonna keep talking. So are you guys gonna stop and you gotta listen?
Mass attracting mass. What was your point with that
Again, you're
one?
gonna stop talking and listen.
Mass attracting mass. What was your point with that one?
Talking, so therefore
No, absolutely not. You want to try and have this pissing contest, motherfucker? I'll be more than happy to match you energy for energy. Let's go ahead and fucking go right now. So you're gonna go ahead and have to fucking match. It's okay. It's okay. I understand. No. Okay, we're literally in the same frame, and we can all watch together. That's perfectly fine with me, man. Let's go ahead and go. So we can see that. That's perfectly fine. We're good.
No, they were not released at the same time.
No, they were. That's okay.
I need to mute both of them. I'm sorry. Okay, I'm gonna withdraw from this conversation, but
I just have a really
you
quick
guys
question.
got to please go one at a time, please, because it's so hard to
It's not
hear.
going to happen. They're not going to let Elbow speak.
Thank you. Just
Please, I have a really quick question for you.
Hold on, Rick. Hold on, dude. Let's just let Elbow and Reds just solve it so we can move on. Actually,
We ain't gonna solve shit.
Yeah, of course, because you always like speaking over somebody. Every time you've been doing this since you got here.
Frame by frame, and you're not satisfied.
Dude,
At this point, I'm done with you.
I just posted the pictures, bro.
Yeah, go ahead. Post them again. Post them with the video so people can see that you're full of shit.
Which is the feather, and the other pin is still there, the bowling ball, and then the bowling ball gets released.
Cool. Let me come back to me when you have people that actually believe you.
Let me ask you: is that at the same time?
Exactly the same time,
Really?
within the same frame. Oh, let's go ahead and watch the video again, and so I can prove you wrong for the millionth fucking time. So here we can see the feather and the bowling ball. Let's do this frame by frame. So this is one frame, and
It won't look at the screenshot.
hang on. Let's go this. So I'm going back frames. So one frame, 2 frame, 3 frames, 4 frames, 5. Oh, look, they move at exactly the same fucking frame. How many times do you want to play this game, my guy?
Again, you're not paying attention. You said they were released at the same time. They weren't.
Yes, they were, because they start moving at exactly the same fucking frame. You
Again, they were
cannot
not
say
released
otherwise.
at the same time. The pin of the feather was out before the pin of the bowling ball.
If the pin was still in the feather, then it wouldn't be fucking moving, dumbass.
Go fucking look at the damn screenshots.
I see that they're moving at exactly the same time on the video, not through your fucking screenshots, dipshit.
Well, the screenshots is from the fucking video, you moron.
Yeah, but you're not seeing the whole fucking video
Are we
per
gonna just
frame.
let this go on? You guys like this? You guys like this conversation?
I just want to talk about where you were going with gravity, honestly.
I wanted
elbows.
My guy.
Again,
this is one frame,
Why don't you see
and
the screenshots?
It won't look at the screenshot.
hang on. Let's go this. So I'm going back frames. So one frame, 2 frame, 3 frames, 4 frames, 5. Oh, look, they move at exactly the same fucking frame. How many times do you want to play this game, my guy?
Again, you're not paying attention. You said they were released at the same time. They weren't.
Yoshi.
There's still some friction, right?
I'm just gonna say cool,
Right?
fine,
There's still
whatever.
support medium in there.
You can believe whatever you want. What was the conversation about the paradigm of mass attracting mass?
I mean, if you subscribe to mass attracting mass, okay?
Oh my
then
god.
Oh no, go ahead, Elbow. Please
No, no,
argue
no, no, no,
about a
no,
half
no.
a frame for
Not
another 30
you.
minutes, please.
I wasn't talking about you. I was talking about his subscription to mass attracting mass.
So what were you going with that? The mass attracting mass thing?
That you have selective mass attracting mass depending on the actual material, right? Like if you have helium gas, which technically by its mass should be flown down to the ground, right? Should be attracted
No, because
towards.
there's some context that you're missing in the equation, which is also the surrounding medium. The reason why we have a density gradient is because gravity is literally in the equation.
Okay, so you do admit that the relative medium matters.
Yes, it does, but it matters a lot less when there's no gravity involved.
So you're saying gravity is the downward force or the downward
Gravity
vector,
is the downward force.
The reason why things find equilibrium is that's your claim.
Equilibrium is what are you bringing equilibrium for? Are you talking about like hydrostatic equilibrium, like why the Earth is a ball?
No, I mean if you have a downward force, right, then that explains why you have relative density like differentials and why things, if you release in certain densities, it wants to find a balance, right? It wants to find equilibrium.
Yeah, so the denser stuff would be further down and the lighter stuff would be further up.
Correct.
Typically.
So in terms of just mass attracting mass, that's not sufficient enough to explain.
Why is it not?
Clouds, fog. There's so many things that are anomalous.
You mean
can easily show that gases are affected by gravity.
So you mean water vapor?
But they weren't interested.
Yeah, you have water. I mean, you have clouds literally filled with millions of gallons of water vapor, but they're supposedly just at the cloud layer, floating, not worried about gravity in the slightest. So there has to be other forces.
The reason why we have clouds is because of
you say gravity. That's incorrect.
Yes, exactly. And did you know that the clouds don't stay up all there because they do eventually come down? It's called rain.
Yeah, but it's because of its electrical disposition.
Sure, I will go with that word salad. Let's try this.
That's not word salad. It's the reason why we have
electrical disposition in this context is most definitely word salad. If we look at the water vapor, we will see that water as a vapor can have similar densities to the surrounding air. In fact, did you know that the air you're breathing actually has some vapor already in it? It's called humidity. In fact, you can get little meters off of Amazon that'll tell you in a percentage how much relative humidity you actually have in the air.
Yeah.
So a atmosphere that already has humidity in it can have pockets of more or less humidity depending on the environment that you're actually in.
Thank you. That was my argument.
So for example, For example, convection currents can tell us where we can see pockets of more humidity and other humidity. If you go down to Florida, you're going to be humid as fuck and will be guaranteed to have a case of swamp ass. But if you go to Massachusetts, you're not going to have as much of a risk of the swamp ass because of the relative humidity in the air, right?
Right. So basically, gravity is selective.
No, it's not. No, it's not. That's
And
not
how do you have relative
that is
humidity in different areas?
The reason why you have different areas is because weather is a thing. There is energy within the atmosphere, and that mixes things up.
Oh, the dynamic.
Yes, like for example, the Coriolis forces, because gravity is not the only thing that is impacting our atmosphere, my guy.
You okay? That was my point. I kept saying that there's other forces other than gravity, and you kept
So
saying
weather.
no.
We spent this whole time to debate the existence of weather. Where were you going with this? Yeah, weather's a thing. We all know this.
That gravity is not a sufficient explanation for why things are contained.
No. Gravity is not a sufficient explanation on its own to explain weather. That's why we have other things that impact weather. Yes,
or anything else about our atmos.
I didn't say that gravity was a single lady, my guy. Gravity likes to tangle with other forces that are out there in the world.
Okay, so when I asked in your paradigm,
she's voluptuous, she's beautiful, and she wants to party with the other forces. Like, for example, she's partying with the Coriolis force over here. She's partying with convection over here. She's getting her groove on, man.
So now he's anthropomorphizing gravity. For fuck's sake.
All I gotta say is curves are fucking hot, man. You gotta agree with that.
Yeah,
gravity wants to party all the time.
John, I just want to know. Why do you think gravity is an answer to how is that a sufficient answer for containment?
Can I ask a question?
Because hang on, you were on to answer that, or do you want me to answer that?
I want John to answer that. Hold on, Rick.
I want to ask a question because we're going around in a circle, and I think this question may get us somewhere.
Go ahead.
So if we're suggesting that, what we're talking about is whether gravity is sufficient as a force to hold the atmosphere of the Earth on the Earth. Now, the question I have is, the argument opposed to this is that gases expand in all directions. Is that an accurate representation of the argument? I don't want to storm anyone.
I kind of lost you. Toon, you want to help him out?
No, I don't need help. What I'm asking is, you said that gases expand in all directions. Is that, I don't want to misquote you. That's what I understood you said. Do you believe that?
Do I believe that gas disperses in all directions?
Yeah.
Yeah, I mean, if you look at kinetic, what is it called? Kinetic gas theory.
Yeah, and you also said that it finds equilibrium. Is that right?
Yeah.
So the question I have based on that is, if gas is finding equilibrium, why is the air pressure gradient not finding equilibrium?
The air pressure gradient is, what do you mean? It is finding equilibrium all the time.
But as you go higher, the air pressure is not. It's been gone for a while, several thousand years or 100 years at least, by several thousand years by anyone's measurement. The gradient is not leveling out. We're not getting closer to equilibrium as the same pressure throughout the whole system.
No, but we don't live in an idealized atmos. It's not just like layer cake. You know what I mean? It's completely dynamic, and the different layers like stratosphere, ionosphere, etc. All these different layers are they're arbitrary in terms of how high they go, because they fluctuate. It's different. Like Reds was saying.
Yeah. But what I'm saying is, gas on the surface is not moving upwards.
Let me be clear about something. Our naming convention is what's arbitrary.
Right, because you can't actually pinpoint this is where this layer begins and this ends every day.
Well, you got to draw the line somewhere, otherwise you wouldn't really have any sort of way to have any sort of demarcation. You got to draw the line somewhere. Where that line is drawn just depends on the culture that you're talking to. Why did we choose 100 kilometers as the Kármán line? It's because it was a nice number to memorize. 100 kilometers. Wow, so simple.
So it's just arbitrary about the line. Yeah, about the line between
space
and
measurements.
Space.
Yeah, measurement systems are literally arbitrary. That's why we have multiple variants of systems like the metric system and imperial system, which I would argue is superior.
Wait, what?
Yes, I am got to draw the line somewhere, otherwise you wouldn't really have any sort of way to have any sort of demarcation. You got to draw the line somewhere. Where that line is drawn to memorize. 100 kilometers. Wow, so simple.
So it's just arbitrary about the line. Yeah, about the line between
space
and
measurements. Yeah, measurement systems are literally arbitrary. That's why we have multiple variants of systems like the metric system and imperial system, which I would argue is superior.
Wait, what?
Yes, I am team imperial. We use miles and Fahrenheit here. Show some goddamn respect.
Freedom units. But the question is why?
So you're anti-American.
Why
you're anti-American because the Americans have space at 50 miles. Sorry to interrupt, but that's kind of important.
I said Kármán line, not where Americans consider space.
It's
well, it's the same thing.
My question is why don't we have the atmosphere rapidly equalizing?
Did you not know that?
It appears you didn't know that, Elbow.
It doesn't matter.
So this is a scientific discussion, yeah, not political.
Yeah.
Well, it's exactly scientific. So how? That's a good point you raised there. So how could we have two areas? It's very unscientific. I agree with you.
It's
You mean it's unscientific to have naming conventions?
No, difference in height of where this thing happens, right? The Americans,
they're called considers.
They're called what?
It's a consideration. All right. There is a difference between what you want to define something and what's actually possible. So, for example, it doesn't matter what the Americans call space. What matters is, can I sustain an orbit at that altitude? If the answer is no, then it really doesn't matter what your definition is.
So how could there be two of them then?
Because different people name different things. They have different milestones. And I have my own.
Were you aware of this, though? Reds,
yes, I was fucking aware of this. I'm the one that's teaching it to you right now.
He's teaching.
Yeah, you are.
Stop getting all hyped up, bro.
It's too funny, man. The one guy says it's scientific, right? And you show that, well, if it's scientific, it has to be at one specific area. So how could the Americans give you space wings at 50 miles when the international community says 60 miles? I mean, that should be.
It's what they consider space. It's what they consider space. But both the international community and the American community both agree that in order to sustain an orbit, you probably have to go a little higher than that. They're in agreement there. Another thing they're in agreement on is that the Earth is fucking round.
Right. I'm sure that's it.
I feel like we're just arguing semantics. But is anyone
not semantics
about why?
I thought we were talking about science.
With talking about
at this point, it was about convention and what people define, whatever. But the point is that it doesn't matter what the Americans define. It doesn't matter what the Americans define. People said that, oh, well, the Fahrenheit, it's the wrong scale. No, it works just fine. You just got to use the right scale when making your calculations. Fahrenheit works just fine. Celsius works just fine. Kilometers works just fine.
So why doesn't if gas needs, fills a container and spreads everywhere, why isn't the atmosphere rapidly spreading, equalizing in the vertical direction? Like you can
since you guys are. That's a good. I mean, could I couple that with another question? Like, since you guys are doing science, cause and effect, what's the cause of gas, so that we can then determine like what it's, what's putting it in motion.
That's a whole other subject.
Well, I thought it might couple up well. Meaning, the guy just now was asking what's
That's a
causing it to go in a
derail.
specific direction, right? I don't know if I don't know.
That's a
You got more
derail, Tank.
comments? You got more comments, or I just like say what I'm saying. So if he's
Well,
asking like, what's the what's causing the direction, right? Like what's giving it the directionality of the gas, right? Like it's
I'm
being put
wondering
into
why there's
motion, right, by something else prior to it, or is it just
And
putting
you're
itself into
changing the
motion?
subject,
Would be
Tanks.
the
And you're
yeah,
changing the
can we mute
subject.
this? Can we mute this guy? I don't know if this guy
Stop
knows I'm
changing the
talking or not,
subject.
but I think we could mute this guy.
Well,
Would
stop
be helpful.
interrupting IC Spin, please.
Yeah. So if we're asking the question, right? Like what's so we have a directionality, a vector of the gas, right? So is the gas right? The question would then be: is the gas putting itself in motion, or is something else putting it in motion? And if something, right? So now we would say, okay, well, if we can find out what's causing gas to exist in the first place, we could find the thing that's causing the motion. So do you guys have any idea on that?
Well, I'm confused because I don't see the motion. That's what's really confusing me. Everyone keeps saying that gas fills the container and gas finds equilibrium, but on Earth we don't see that. We don't see the same pressure. You go 300, 1,000 feet high, and which is not high, it's like 300 meters. Go 1,000 feet, and you see a massive drop in atmospheric pressure. The sort of drop that would cause like huge storms, 100 km/h winds, like crazy weather. Then that happens in just you'd have that over 1,000 miles, and it would cause tremendous weather systems. But then over just 1,000 feet, you have this huge change in pressure with no crazy wind, no anything. It's just like totally peaceful, and I don't understand that.
So then, scientifically, what could we do to manipulate it to cause the gas to go in motion, so that we can then find out we can find out what's causing it to not go in motion?
You can't really do a scientific experiment on this, but you can observe what happens at sea level, and you could be like, at sea level, when you've got like 30 milligrams of mercury change over, I don't know, 100 kilometers, that's like a huge cold front with like massive storms coming through, right? It's like a massive difference.
Well,
Like you have like, I think the biggest
that would
ever
go back to
recorded.
relative density, like the mercury in relation to the surrounding air pressure. That's what it measures. But
nothing to do with
could I do? Huh?
We can just look at it, like look at barometric charts, and we can be like, oh, look at this crazy cyclone happening because of like, whatever 80 milligrams of mercury difference, which is like the biggest ever recorded on the surface or something. And then we've got like 80 milligrams of mercury difference between the top of a small hill and the bottom of the small hill, and you're like, wow, that's really interesting. Why isn't it equalized?
Yeah, it's relative. I mean, they've shown that to be relative density, but with the pressure pushing through the capillary, the mercury. But like you said, I can't. You're saying like there's nothing scientific we can do to experiment and cause the gas to go into to move. Like what if I added more gas? Would it go in motion? What if I expanded the area or contracted the area? Would this cause it to go into motion?
No, but the question isn't what causes it to go into motion. The question is why it isn't in motion.
Right. So why is it right? So then we could perform science, right, to see what causes it to go in motion. This is why I asked the question. Maybe it would couple up nicely. What's the cause of the cause of gas? Like what's creating it? What's putting it in motion to begin with? Unless we're saying it just ex nihilo just began and just popped into non-motion existence. That would be hard to science.
Well, I think the globe would say that the cause is gravity, and that matches pretty well with if you do the calculations on it.
Gravity is their god. Oh shit, that's everything.
I'm curious.
Well, I don't know. Maybe it did sound like you were answering that gravity is the cause of the existence of gas, but that might not be what you were saying.
I'm not saying that. No, I'm saying that I'm asking the room. Well, someone in the room said that gas fills a container and that gas finds equilibrium. But when we look on the Earth right in front of us, we see that is not what happens. And I'm curious as to why we see that's not what happens.
Well,
if it's just
we're mixing it up a little bit because even when they say that there's gas pressure, they say that's the force colliding with the walls of the container. So when you're saying I'm observing gas to not be in motion, science says it is in motion. Like, you know what I mean?
The molecules itself may be in motion, but the overall direction of the wind and the particles is not overwhelmingly in motion on a large scale, on a micro scale perhaps, but that's not what we're discussing.
All right. Well, I don't.
Just look up kinetic gas theory, Rick. Sorry, tank. No tanks. My bad.
No, good. I was just going to try to make it something.
It's simple, dude. It's just like kinetic gas theory is just that. I mean, unless someone can show me otherwise, it's pretty solid theory.
What does it say? I'm not familiar with it.
It's basically ideal gas law, and you know so like the amount of pressure versus like the volume, and then it's like its temperature, like all those three things, like the different variables will directly like equal its energy output. So if you change the temperature, then you're gonna get a different energy output. If you change the volume of it, you're gonna get a different. You know what I mean? Like all three of those things are interlinked with kinetic gas theory. So like for example, if you have a propane tank full of gas, okay, and you have that gas tank super cooled versus it being heated up, what do you think has more energy?
Well, the
like, what do you think?
Warmed up one, obviously.
Right. So there's like a proportion, like a proportional rate change essentially if you change any one of those variables. But all
Like
of those
if I had some sort of like a substance that was sitting outside, I'd imagine you put stuff in the freezer, it lasts forever, right? But if I have it outside, just sitting on like a table, it disintegrates. I mean, I guess evaporate. I don't know if I call it evaporates, but disintegrates, and eventually the food or whatever it is sitting on the table disappears. I guess you could say. Did it turn into a gas due to the energy of like if I put it out in the summer, it'll be going quick. The winter, it'll sit there all winter. Is the sun heating it up, turning it into a gas?
What?
Like a banana. You throw a banana outside. It's gone. It's gone in like a month. No more banana. Where'd it go?
Why are you throwing good food outside?
You never heard of bugs and worms and?
For when SE said demonstrate a gas ball inside of a vacuum, so you would say that no, that actually makes sense. That tracks versus the same thing that I'm showing you here. Like you're saying, like I'm asking for the impossible, or I'm not demonstrating it. I'm literally demonstrating that the technology to fake the moon landing footage is possible.
What you're
without
demonstrating
computers.
I put some footage in the chat. Yeah, I put some footage in the chat that shows like they may be on harnesses. So like there's an example of some reasoning why we think that maybe the Earth, that the moon landing was faked. There's an example.
So
of
what you've demonstrated is it's possible to overlay two different images.
Yes.
That's okay. The first image is video footage, which is fine. I'm not disagreeing that that's real.
Mm-hmm.
That's obviously real people dancing. Yeah, I agree. The second image that they overlaid was not real. Do you agree that the second image that they overlaid there was not real?
Okay.
That's yes or no question. Okay.
Yeah.
That's fine. So if they need to overlay a second image, that image needs to be, in 1960s technology, photorealistic. Because the moon landing was very realistic in terms of the footage. It looked very real in terms of the quality, in terms of the way that the dust behaved. Okay. Now, the problem that we've got is that the issue isn't that it's not possible to overlay.
Have you looked at the video that Issa tagged you in?
No, I'm talking to you. The issue isn't that the footage is impossible to get a picture of a dusty area. The issue is that it's not possible to get footage of dust behaving like that. So in 1960s technology, you're going to have cartoons or real footage. There was no CGI. There was no AI.
But you say there's no CGI, but I literally just showed you that it did exist at that time.
Well, no, it's videography effects, not CGI. CGI has a specific meaning.
All right, computer generated images, but still, what CGI basically is: composite imagery, basically illusions. So like the illusion that this astronaut's actually on the moon. Like, so you see that video that he posted and tag? I don't know if he tagged you in it. I'll tag you in it. So this is what Issa was saying. Like, doesn't it look like they're on harnesses? Could you actually concede that it might be possible that they're just on harnesses?
The issue that we have is that the dust, and this is the issue we keep talking about, the video of the dust was not fakeable at the time.
Well, see, that's where you are wrong.
Okay, show me that it was. I'm not talking about it. I'm not talking about overlaying two images. Just
That's a presupposition, dude.
You don't know
How is that
that.
presupposition?
How do you know that? How do you know that?
I don't, because everything I've read and everything I've seen indicates that's the case. That is my belief, and I'm open to be proven.
No, how do you know that? How do you know that they didn't have the technology back then?
Did you hear what I just said?
You didn't say anything with substance. Just rhetoric. How'd you know that?
I said,
how'd you know that?
That is my belief, and I'm open to be proven wrong.
Okay, let's watch this. Watch this video that I tagged you in, that Issa posted for you. Issa, what was your question exactly?
I was just wondering, like, you asked for specific, you asked for footage of the moon landing that, like, would lead us to believe that it may have been faked. And I'm just saying there's an example of it. Like, instead of going off into, because basically it was kind of granting you a little more leeway in the sense of like, hey, look at this interesting tech, because that's interesting shit. And that's maybe the way that they could have faked it. But like the obvious, real, like, old school flat earther thing is just show you the moon landing footage because it's so that
he's breaking up for me.
You roboted, but I'll translate. It's retarded looking.
That's not very good as an argument.
Yeah, neither is saying, oh, it's impossible for them to fake dust.
Okay, so then
how do you know that? That's a claim in itself, by the way. You have to show that it's impossible.
That's proving the negative. It's impossible to do that, as you would be aware.
You're making a positive claim.
Yeah.
I didn't say that. I said I do not believe it's possible. Prove otherwise.
You said they went to the fucking moon. That's a pretty positive.
Now he wants to play
claim.
the neutral ground, dude. Now he wants to play the neutral ground. That's what
it's
like atheists. Well, I'm an atheist until you get confronted with evidence of being an atheist, and you can't provide evidence. Oh, well, I'm really agnostic. You're doing the same thing.
Atheism is that you do not believe in theism.
Yeah, you don't believe that they were able to fake the moon landing, but then when we confront you, well, what's the evidence, right, for your belief? You're like, well, I just don't know. You're agnostic. So you're agnostic?
That's all right. I wouldn't get too worked up over this guy. This guy is the same guy that said you don't need the stars for celestial navigation.
Right, you know what that looks like in low gravity.
About celestial navigation.
I'm just saying that was a statement that you made.
We can,
because he knows that evidence of absence isn't absence of evidence.
We don't need the stars.
You don't need the stars for celestial navigation.
That's not what I said.
That's quote unquote.
Clip it. Show me. Post it.
Yeah, well, you did say it, bro. I will clip it.
Apparently there's a few Hollywood movies though that fake the moon landings.